Does this thing work?
Oh, yeah.
I feel louder. Seems like it works.
Hello, everyone. Welcome to the third annual Libre Graphics Track here at SCaLE. We are a couple minutes behind, so we're going to get started. Today, talking to us about rendering in 3D in Godot is Tom Lechler.
Hello. Thank you all for coming, risking virus and surviving lost time and everything. Let's see, so this talk is specifically about my adventures using Godot in VR to simulate big rotating space stations. This is a very obscure niche of video game development, but let's see what we can do with it. Most video games kind of fake the physics of rotational things, so thought I like to explore that sort of realm. So here's a quick video of the kind of stuff I've been working on, just different VR things. VR in Godot Engine is really new, so everything is extremely experimental. I've always wanted to make simulations that give players an idea of what it's like to actually be there, not just like see it on a flat screen, but if you're there, what happens when you're there? So let's talk about space stations in general. In the world of hard sci-fi, you kind of want to stick to, or you sort of stick most of the time to basically known science. And when it comes to gravity, your options are pretty limited because there's basically no gravity, because there's microgravity. You're technically like orbiting the sun or something, but you can't really feel it when you're floating in space. Just like if you want gravity, an easy way is to spin something around and sit on the inside of the surface of the thing that's spinning around. Just like you have a bucket of water and you spin around really fast, the water stays inside. Let's see. And through the years, through NASA and through other things, there's been like practical designs for making space stations from known technology. So Wikipedia has a big page and other space habitats. This one's probably the most impractical one. It's like gigantic thing. Each of those barrels spins in opposite directions, so things kind of, it equals out the twisting motion theoretically. You can support millions of people inside these things. This is an O'Neill cylinder, it's called, after Gerard O'Neill, who in the 70s was trying to get NASA to build these giant space stations in space, and some senators didn't like it and kind of kicked him out eventually, so I hear. So part of my interest in the space station stuff, I wanted to see what things were like when you throw things around. Like you see the movie 2001, there's the station where it's the guy's running around inside for exercise. And it's a very small radius. So I built something in 2 dimensions, this was a couple of years ago, to kind of get a glimpse of what's actually happening. So one frame is what it looks like when you're inside. The other side is what it looks like if you're outside watching this thing spin around. If you throw things in one direction, the balls behave sort of like it is in just naturally, things fall to the ground. Things start to get weird as you rotate around and throw it in the direction of the spin. So like if you throw straight up, things don't actually go straight up and straight down. They sort of bend off to the side. And the more over you go, the weirder things get. So on the left, you can sort of see where the balls are going. Since there's no other gravity, when you throw something, you release the ball is actually traveling in a straight line. But since you're sort of traveling along with it in a way, you don't necessarily see where it's going. And if you're fancy and you get the speed of your throw just right, you can make some pretty wacky things. Like imagine having silly string and squirting it around. That'd be fun. Or it would get you banned from the space station, depending on the administrator. Okay, so that was a 2D version. I've always wanted to do something in higher dimensions, like something that you can just walk around inside. This was kind of a first prototype. You see these other controls on the bottom. Those weren't functional yet, but this is just a kind of a duplication of the 2D scene where you throw stuff around. I implemented a teleport, which is kind of tricky. I'll get into that in a second. So just watching it on a flat screen, you can't necessarily see, like you don't get a full sense of what it is to stand there and throw something. Unfortunately, VR is like it's like the perfect simulation medium, because you have this thing on your face and completely controls what you see. You have the controllers that track pretty well, assuming your computer's beefy enough, I guess. So it's very easy to like set up something like this. It's a great place to simulate. Aside from actually building a spinning station and standing in it, VR is the next best thing, with only half the nausea of reality. Some people get sick with VR naturally, but if it's spinning in space too. There are some studies that say you might get sick, but if you spin slow enough and you have a big enough station, you get less sick. Okay, so that's what we're talking about. Now I'll kind of dig into how to use Godot to make these things. So about a year ago, this guy named Bastian Olich made a plugin for Godot to use Valve's OpenVR to have VR operational within Godot. Other game engines, the proprietary ones like Unreal and Unity, they've had VR going for like all the time the major headsets have been out, but Godot has been a little bit lagging, and now it's slowly catching up. There's still some glitches, but thanks to Bastian, there's now that capability. So he's also made some demo scenes, so you can dig into his scenes and figure out how to do pointers and different controls and getting button feedback. Like with everything in Godot, it's a kind of a new engine, and it's gaining in popularity. And every couple of months, there's some new feature that's like really cool, and like more people get on board. They just got an epic mega grant from Unreal to actually pay people more to work on it, which is great. Programmers need to eat too. You can also do AR as well as VR in Godot with the same kind of framework. So it uses a lot of similar technology, like just tracking cameras and whatnot. The Godot main site also has a VR tutorial. I don't think Bastian wrote that, but it has other things like wands, similar technology or like implementation, but done in a slightly different way. So you can see different approaches for how to get stuff done in VR with Godot. So about VR in Linux specifically, I prefer to use Linux because I've just been using it for so long. I have all my tools set up just like I like. VR is a little bit limited. The things that you can use relatively seamlessly with Linux, you have to be running Steam VR, which is proprietary. So if you're okay with that, then you can run. The Vive works pretty well. I have a Vive. I don't have an index. I'd love to have an index, but I've heard that the Valve index works mostly in Linux. There's like a pass-through camera on the front of those, so you can sort of see the world outside you. Like if you approach a wall, it could fade into what the cameras are seeing. That doesn't quite work in Linux from what I hear. Valve has been pretty friendly, so I would expect that to be fixed over time. Vive works pretty well. Facebook's Oculus, their Oculus Quest is something that doesn't have wires hanging off. That's a great feature. However, Oculus software doesn't work natively in Linux. I found a couple of people talking about programming for Oculus on a Linux platform, because I guess Oculus is running some form of Android, I believe. So as long as you can compile something and kind of sideload it on there, it's a very circuitous process. I wouldn't call it a natural way to work. Vive works pretty much out of the box with Bastian's plugin. So with my Vive and my revolving goal, I ran into a number of issues stemming from trying to do things in a rotating reference frame. It's kind of just a basic list of things that are issues. When you have a gigantic space station, you want balls to be able to stop on the edges. Like I hear the balls, when they hit the edge, they just kind of go through and they keep going. I didn't have any form of collider implemented then. The the bigger things that you have, the more checks have to be done. If you throw something around as a collider, the physics system has to check whether one collider hits this other gigantic collider that has thousands of pieces, and that can be very inefficient. There's a couple of different ways to work around that, like having a special check for kind of co-opting the physics system, putting in an extra check if you're near the cylindrical boundary, just reverse the velocity. That's kind of what I've gone with because it's the easiest to implement. Other ways that I'm kind of toying with is I have a kind of a moving collider, so you only have to make objects for a small portion and then just kind of keep track where objects are. So the physics engine only has to actually check a very small area. It's much less resource intensive, and VR is all about optimization. You want to run about 90 frames per second. If you get less than that, people tend to get sick. It's just something to watch out for. Let's see, objects floating around need to detect collisions with the huge shell. Another big problem is that most of the tools and the examples and demo projects assume that gravity is like straight down. And in Godot, y is up, so negative y tends to be gravity, and there are multiple parts where you have to either turn off gravity entirely and do something else, or like the teleporting is, for instance, the object that sticks straight up. There are many parts in the example code where if you move along the cylinder, it just your object kind of starts going up. It wouldn't orient properly. So I had to learn all about translation and matrices and the Godot system, which is mostly good. I've used Unity Game Engine a lot, and the transform language in the code is a little bit more straightforward, I think. In Godot, sometimes there's, like they use the word translation for moving in a straight line, but sometimes it refers to in your object space, and sometimes it refers to the parent space of an object. And there's another completely different transform for a world space of an object. And there's a little crossover that's a little confusing. Once I figured that out, then I can make the teleporter move and like orient itself properly. The teleport line that casts a parabola out, so it's kind of a dotted line. It took me a while to realize that in there is also a hard-coded gravity vector going straight down, y negative. It took me forever to figure out that it was inside of a shader. So the parabola that's being rendered is using what's called a vertex shader. It's basically just a rectangle, and then at the point of rendering, it's bent into a parabola. So each frame I have to pass in what is the actual down direction. Then I could get the parabola pointing in the right direction to teleport around. Also with rotating reference frames and the physics engine, picking up and dropping things can sometimes be a problem. Because when you pick something up, it's no longer a free-floating object, so you have to configure stuff around it and sort of remove its velocity. And then as soon as you pick something up, you're in this big thing that's moving, so suddenly you're moving kind of in a non-linear direction, and keeping that same velocity, like when you release it, it's a little glitchy. It's kind of difficult to synchronize picking up and dropping off of velocities. One thing that I found in Godot I haven't found a workaround for, like 3 times out of 4, when I start the Godot playback, the frames per second drops to like 10 or 11 for unknown reasons. It seems completely random when it does or not. So I've got to stop it and then restart it. Like just stop the playback and restart the playback. And then suddenly it bumps up to 90 frames per second. So I wouldn't say VR in Godot is like perfect or like ready for production, but it's enough to be getting on with. And like I said, Godot development is advancing so quickly that I have high hopes that stuff like this will be ironed out fairly quick. More people are getting into VR with Godot. I found a few people on Twitter especially that are like posting stuff, but not a lot of people using it yet. Okay, so that's the basics of just like getting VR to start. So this is kind of a first test scene. Just walking around stuff and throwing balls around is one thing, but once you're in VR, you don't want to have to like lift up and mess with your keyboard to like change different settings. So I did controls. This was the first attempt at controls. This is a very naive implementation of buttons. It doesn't rely on the physics engine at all. It's just a controller that has kind of a ball around it. When it approaches another thing, it activates an animation. So you can turn this engine on and off. See, one thing about assets, like in this engine, I just found something on BlendSwap for, you'd think it was a CC BY Blender file. So I took that. It was just a jet engine for an airplane, so I kind of cut it in half and reversed it, so now it's perfect for a space station instead. Although it's using its own fuel. It's not like an actual jet engine, it just looks cool. Other places where you can get free assets, something that's easy to use, are Smithsonian, for instance. They just opened up like thousands of images and a whole bunch of 3D models that you can just download and repurpose. Video game production requires so many things to make it work that it's doing it all by yourself is very difficult. It's hard to pay people with exposure dollars and convince people to work for free. So it's very expedient to use objects that you can find. If you're a starving artist like me, it's helpful to have sources like this. Sketchfab also fairly recently has a whole section where it's a bunch of CC0 models, so you can just download and use. Sometimes on here you can get some low poly stuff that works pretty well. One problem with free stuff is that often it's not quite what you need. Like, it'll get pretty close, but like maybe it'll just have a texture, but it won't have a bump map. Or maybe you want some extra shadows from ambient occlusion, and it's not provided. So, but you can bring it into Blender, kind of try to mess around with it. There's some other material tools that you can take an original image and then generate bump maps from it. I believe GIMP can do that, like make normal maps. Pretty sure I've used it there. I think Krita can do it also. Take an image and then generate other maps that you can use. And one further note about modeling. When you go into games, especially, you need things to be easy to access and walk around in. So always name things meaningfully. Like in Blender, you make a cube and you duplicate it, it'll be like cube.0 whatever. These are not meaningful names. Never do that. You'll hate yourself in the end. And similarly, parent things properly. If you have a bunch of things that are supposed to go together, it's convenient to just like group them together. Otherwise, you'll have a list of like 100 things, and if you set this project aside, come back a month later, you're not going to know what you're doing. Or if you bring someone else onto the project, they're going to hate you. So it's name things properly, do parenting properly. Also, when you're modeling in Blender, for instance, you can set the world scale. That's really important when you go into pull things into Godot and then go into VR. Because you might make a ball that you think is like this big, and then you get into the VR, and it's actually this big, like really huge. You can avoid those problems if you just like make the object in the proper scale at first. Sometimes it also confuses the physics engine. If you have a ball or something that's scaled weirdly, the physics engine will not interpret things correctly. You get some weird movements, which can be fun, but it's also difficult to debug. Okay, so those are kind of the basic pieces, teleporting objects. So I put them all together into this next experiment, which is kind of a dumbbell station. One form, it's like the simplest way to manufacture a station that spins around, something with a truss or a big rope between it, and then have two things on either side, just like you're spinning a bucket, or maybe two buckets around of water. And I put an elevator just to make you especially sick as you move around. I don't really tend to get sick myself in VR, but when you're standing there and you see the entire field of view just as stars and it suddenly starts to rotate, that is really disorienting. I was not expecting how kind of strange that was. I almost fell over a few times, but it's kind of interesting. I think I've mostly gotten used to it. And I needed a backlight. The previous version of this video was really dark, so I decided to put Jupiter in as a backlight. And here's another iteration of the dumbbell concept, where instead of just one station, you have 4 stations. And you can also do overlays like this in Godot. It's like a 2-dimensional scene that you're kind of tacking onto a 3-dimensional scene. So this is kind of, if you imagine a cube, and each 4 faces of a cube, excluding the top and the bottom, if each of those has one of these dumbbell stations, and then have them rotate around, they rotate in such a way that they're like gears meshing together. So it looks like they're going to smash apart, but they never quite do. I would totally live there. I think that would be fun. Okay, so that's the engine had kind of just basic push controls. So this was the next iteration of making controls in Godot, a little more complicated than just using a pointer to call a function on an object. In Godot, you have objects, and each object can have one script attached to them to do whatever you want in it, or you can have subnodes that have other scripts on them to do other stuff. So each of these controls is kind of a separate conglomeration of nodes with different functions to call. There's a few different classes of things going on here. So like the thing with the ribs on it, that's just something that goes up and down. So the controller has a kind of a contact hover ball around it, and whenever it comes in contact with the control, the track control, it detects that there's a collision going on, records the position, then when you move the controller up, it just takes that distance you're moving the controller and translates it into appropriate distant movements for the controller. It's not a full like actual physics system. Physics gets really complicated in VR because you can't really control actual physics with your hands, because you can go wherever you want except for physical stuff, but in VR there might be something right in front of you that you're not supposed to be able to go. Your hand can go right through it. If you have an actual physics object tied to your hand, it's going to be kind of unpleasant. Like you might go into it and then suddenly the physics engine will say, oh, there's a conflict, I don't know what to do, let's send this object 10,000 units away. So, but this system is much simpler, where it's just an area, there's no actual physics to it, it's easier to control. There's been some things that do physics in VR pretty well, like Boneworks, for instance. It's a game that's does pretty well. You have to have continuous movement, so some people get more sick with like continuous movement in VR rather than teleporting. But the technology keeps getting better, the frame rates keep getting better. Okay, so that's controls. The next step is being able to grab stuff rather than just throwing balls out of my hand. So this was experimenting with the physics engine itself, things I can pick up and release. This environment is not spinning, so things kind of work pretty well. That's sort of what the physics system is designed for. You can pick up and drop stuff pretty easily. When the ball bounces, there's a trigger on it. So when it detects a bounce on the ground, it changes the lights, or the hand has a trigger on it. So when you cross the line, then like press the button, it changes. Uses the same function to control just a color on a material. It's pretty straightforward to do. There's just a few lines of code in Godot to access materials and change stuff. It's very easy and accessible. Another thing about collisions, Godot, like other game engines, can do layers and masks. So you can assign one object to be on a particular abstract layer, and you can tell it, okay, I'm only going to collide with this class of object. And you can set up really complex interactions. Like you can set your controls to be on one layer, and then all of your objects on another layer. And so maybe you can only pick up some types of objects. Maybe you have to be holding a certain tool to pick up some tool, some other basketball or whatnot. You can get pretty complex arrangements of stuff. So for the basic physics stuff, I'd say Godot is on par with the proprietary stuff. Then this was kind of bringing it all together into a single round station, playing basketball. That's kind of fun. So finally I was able to simulate just like the 2D version. Pick something up, throw it into space, fail to make a basket, and repeat. And you might notice that it bounces really hard off of that board. That's kind of the glitchiness of rotating the entire station in Godot. One way around that I haven't quite had time to implement yet is, instead of rotating the whole station, have the stations stationary in the Godot world space, but rotate the background. Then each time, every frame you can change the velocity of objects. So since objects are just rotating, that's mainly what's changing, not the actual magnitude of its velocity. So each frame, just change the direction your velocity is going. Then you can have much fewer glitches in like picking up and dropping objects. Haven't had time to implement that. it makes it harder because you have to render the background somewhere else and then kind of attach it around. Yeah, it's complicated by the fact that the giant round thing is not an actual physics object. It's just something I'm like trying to intercept the physics engine and do other stuff. So that basketball stadium is still pretty small. Like a lot of the NASA proposals in the 70s, for instance, the Bernal sphere here. This is a painting by Rick Giddis, I think his name is. It's this big, massive space station. So this is considerably larger than my little tiny basketball stadium. So there's numerous problems in trying to implement something this huge. I haven't implemented the little like garden party down there yet, so future versions perhaps. So how do we actually up the scale of things now? Again, with video games, optimization is very important. With VR, doubly so. Everything has to be rendered twice, once for each eye, and both of those eyes have to be like 90 frames a second. Technology is advancing so rapidly, so things will get better and hopefully cheaper. When rendering happens, there's a bunch of objects. Each object has different materials. And to render, say you have 1,000 trees, and you want to render all of those inside of this big ball. One way to do it is just make 1,000 trees and then render them all individually. And it requires a bunch of draw calls back and forth to your rendering card, your video card. But this is very inefficient if you have instead 1,000 instances of an object, and then maybe make a custom shader to have different foliage or like different bending of things. You can get away with only a single draw call. Godot has something specifically set up to handle this called a mesh instance or a multi-mesh instance. So you can have like thousands and thousands. I did one test that had about 10,000 little disk boxes, and it barely slowed down the 90 frame per second. So I was very happy with that. So I think there's a way forward to make something that's fully walkable around, that has lots of different variations of stuff. And this was kind of my first, whoops, what is that? There's also menus in space, I guess. Okay, so the first example of trying to scale things up, and this one has 3 different mesh instance objects, and each of those instances has like about 100 things going around. The stairs on one side are one object, the stairs on the other side are another object, and the pathways are a third object. And it works pretty well. I still get close to 90 frames a second. One thing is trying to move the colliders along with the scene. I have in here, you can walk up the steps, but there's only colliders on a tiny portion of the whole thing. So if you move across a sector, then the colliders just like move to the side with you, so that you only have to check, the physics engine only has to check particular small areas at a time. So far, it's been pretty efficient. I have a lot of plans for this one. Those big spikes that go up the ribs, those will eventually be trees, so you can take an elevator up and like walk around tree branches. That's my goal, not quite there yet. So here's we're trying to bring in my throwable objects into this new station and trying different ball types and interaction levels and custom shaders and other stuff. Each of these mesh objects within the bigger multi-mesh thing, you can have as many materials as you want, and each material can have different shaders on it that do like deforming or different colors or other custom effects. Or you can have star children just kind of hanging out. And the star child, by the way, it's built from 2 CC0 assets. I think I got those off of Sketchfab. One was just a baby head, and another was a hand. So that by themselves they were great, but I wanted to use them together. So I could use Blender to kind of blend them together, do some sculpting to build out an arm. Having assets that you can download somewhere is a great help for speeding things along. Speaking of models, if you build things in Blender, sometimes exporting and then importing into Godot can be sort of problematic. Some formats work better than others. Prior to the new 2.8 version of Blender, there was something called a better Collada exporter that was pretty faithful, keeping the Blender setup and then importing into Godot, but that only worked in 2.79. Then when the Blender 2.8 came out, which has much better features pretty much across the board, that part didn't work anymore. Then for a while, you could export as GLTF or GLB, and those imported into Godot sort of okay, but often little glitches. Lately, though, in the Godot 3.2, the most recent version, I've had almost no problems importing GLBs. That includes animations and materials. And sometimes if you build up a whole node system for materials, that's not going to translate so easily. But if you have just simple PBR materials with like bump maps and other stuff, those import pretty easily. And the previous one, I felt kind of bad about throwing the little baby into the air, so I made a part 2. So I made a little kind of like space baby bouncer to stick it in. But you never quite know what's lurking in space, so. And since that guy stole my child, just hop on the monolith and take off after it. And the dinosaur, again, I think that was on Sketchfab also. That was one of the models that it had a great texture to it, but there was no normal map, so it just looks kind of flat and shiny, and it's not quite perfect. There was no rigging to it, so all that extra stuff I had to do myself. The dinosaur did not come with the rotor blades, so I had to add those on specially. Yeah, so this is in Blender. Adding in rigging, trying to do some animations, and then import those into Godot. In Blender, you can set up IK chains, where you just have a string of things, but you only have to pull one thing, and then it pulls everything else. It's still all on a flat screen, though. Sometimes that can be, especially after using VR a bit. I've done some sculpting in VR, and it's amazing how just more intuitive and immediate it is to do those things. But especially in Linux, there are no tools that allow you to do that in VR yet. So I've added that to my to-do list. Who knows? They're like clicking around in Blender and adding all these things. It takes forever to like make something that's like reasonably good. But with VR, if you can just like see the thing in front of you, just put things in 3 dimensions, it's much more intuitive. I think there's a lot of potential there. Here's the animation attempt at grabbing stuff. Godot has an animation tree. So if you have multiple animations, you can set up this kind of 2-dimensional grid of how you want things to perform. So it's an easy way to blend different animations. So you might have one animation that's like grabbing, another one that's like rotating the blades, and you can kind of put those together. And you might notice one of those rudders is like underneath them like a unicycle. That was not intended. That's one of the few glitches I found importing stuff via GLB file format into Godot. Just sometimes things kind of get squished around, and it's not quite seamless, but it's certainly enough to kind of test things out. If things pop up like that, I've been able to just delete those extraneous objects, and then there's usually been enough to work around the peculiarities of Godot importing. Many things about Godot. So I have this long growing list of quirks about Godot that kind of annoy me. Like, for instance, this is all just a single screen, and when you start to do game development, you might want to have one window for like a model, one window for your scene, another window for script editing. Maybe you have multiple monitors, but there is no multiple monitor support natively in Godot. But that's changed as of like last week. They finally implemented multiple monitor support, essentially, where you can have tear off windows and spread out your workspace. It's like every month, sometimes every week, they add new features. It's pretty dramatic to watch the speed of development for such a small team. And one thing about making videos of VR stuff, these are the tools I usually use. They're all open source, cross-platform stuff. I've basically had no problems recording video and then putting stuff together either with sound. I use Kdenlive for the actual video editing. Special concerns about making videos in VR. Sometimes I'll record something and then I'll go to watch it, and I was accidentally standing like 30 degrees off kilter and I didn't realize it, or something that I knew was sort of in front of me. I just intuitively knew it was in front of me, but then I just like watched the stars or something, and then I go watch the video and it's just me watching the stars instead of the thing I was actually trying to make a video of. So it's just other weird concerns to be aware of when making VR marketing materials. Godot has it has some add-ons, just like Blender has a million add-ons. Sometimes you get the main piece of software, but to do the really cool stuff, you've got to happen to know or stumble across this add-on that does everything you want. Like in the earlier video, there's a big truss that goes between the dumbbell station. That's part of an ArchiPack plugin for Blender. There's just a thing, I want a truss, so you click the button and it gives you a truss, then you can export it. It's very seamless and looks pretty good. So this guy, Calino, I think he's a Godot developer. He has this gigantic list of resources that can go along with Godot and help speed up development. I put together my own list of resources, like the Smithsonian link and some other stuff that I found useful in developing all this stuff. And my next stop is to go to Mars, I guess. No one really knows what the effect of limited gravity on human bodies are. We have a lot of data on 1G gravity and a little bit of data on 0G and nothing in between. So even if we go to Mars, like certain billionaires want us to do, I guess, we don't know if we're all just gonna like grow really weird and die young or something. So if you want to have 1G, you can do a rotational environment, but it's basically a conical shape. So you have to stand on the inside of a cone rather than a cylinder and spin that around enough. And then you can get back up to 1G, hopefully make your back grow straight or something. So that's my next simulation experiment. And I guess that's my talk. That's what I've been doing. If you have any questions, I would love to answer them.
Thank you, Tom. Does anyone have any questions? I'm like mildly nauseous. I have bad motion sickness.
For an actual implementation in some of these, would some of those problems be lessened if you were to use a local gravity system, but show the further off the backgrounds and those things as rotating elements to give the impression of the overall rotation? But since in those cylinders and in those gravity, in those rotating reference frames, the local results for the most part are similar to whatever G you decide to go with for the station. So would it have been easier, or would it be easier to go forward for simulating something like that, to say I've got local gravity where I am, it's going to act like normal gravity for the most part, for most things, and then let all the other views look rotating from my reference frame, even though they're really not. Is that like a viable path forward if you wanted to?
In some situations you can, like the bigger radius you get, the more it resembles actual gravity. So past a certain point, things are not going to behave weird unless you move up toward the center. And the problem is, if you want to be able to walk around anywhere in it, if you want to have elevators that go to the center, then things exhibit the peculiarities. Then having a local gravity that just like forces things to go straight down, it'll end up making them just go straight down. It won't have the strangeness. It's very direction dependent. So even if you're throwing something at the same speed one way, it's totally different than if you throw it the other way. It's very difficult to simulate that with only a single gravity override.
so in addition to stuff, to modeling stuff moving through the air, you do you also have a plan to make it so so that when you're on the ground, like that depending on how wide the radius is, it'll actually like instead act kind of like a slope and have stuff like rolling back due to the a bit is when that happened when that happened in a real um, Unreal cylinder.
Yeah, to an extent, yes. That's one of my biggest problems right now, actually. If I throw a ball around and it gets close to the ground, quote ground, if the velocity is slow enough where you would expect the ball to just kind of stop, the collision detection there's just enough rounding errors that instead of just stopping, the ball just like behaves really weird and shoots off. So in an actual environment, if it's just a flat surface, a cylinder, you can still have things like fall down and stop and stick to the ground. There's enough friction to kind of keep it staying there. So you wouldn't necessarily see a lot of rolling. On the conical environment, like if you were to build something on Mars, that's definitely more of a problem. There's only like a sweet spot where something would kind of stay on the ground. Otherwise, it'll kind of roll off to the side, either up or down. In an actual environment, you probably want to have enough furniture and like little potted plants around to prevent things from rolling around in strange ways. Just in basic cylinders, I don't think that would be so much of a problem.
So, but in certain environments, if you wanted, if you wanted to have a cylinder that was narrow enough, attempting to make it act as if you were standing on a slight slope, be a way to implement that, or something. Like basically, if something is meant to be at rest on the ground, like telling it, okay, instead of pretending you're on a flat surface, pretend you're on an unlevel surface. Would that be a way to implement it?
To use the pure physics engine, there's not, even if you tell it to move a little bit just with forces, it'll still kind of move around a little bit. What I'm going for now is instead of trying to use the physics engine to simulate that either with slightly sloped walls to get it to stay, I'm just trying to detect the velocity. If it's low enough and near enough a floor, then just like flip a flag so that it's no longer a physics object, it just sits there. And then when something else comes in contact with it, then turn it back on to being a physics object, and then it'll bounce around. That seems to work pretty well.
All right.
Yeah, it's mostly rounding errors that cause these glitches. So if something's just purely a pure cylinder moving around, it's not going to roll too much.
It's just a thought that came to mind.
Thanks.
Any other questions? No? Thank you, Tom. Very
All right.
interesting.
Thank you all.
So we're going to break for lunch for an hour or a little bit more. We'll be back at 1:30. John Cruz will be talking about open SCAD 3D printing. I heard there's going to be stage magic. You won't get that in any other talk here.
Kind of a giveaway, maybe?
Yeah, and it's stage magic and toys.
Check 1 2. Check 1 2.
Testing, testing.
Check 1 2. Check.
Just stop by, you're in good shape on the batteries. Do you use the handheld or the wireless lab?
Wireless.
Good. Okay, power button is right here.
Mm-hmm.
So it's off now till you get situated here. I'll circle the wagons and check up on you. Let us know if you need anything.
I promise people stage magic.
There'll be at least some. At least one event should function. I also promise people toy surprises, so as long as not too many people show up, y'all will be covered. Otherwise, you'll have to hit me up for a rain check.
You want to give people another couple minutes to wander?
Yeah, sure.
Like that. Welcome back, everyone. I hope you all had a successful lunch. Up next is John Cruz of Inkscape fame, talking to us not about Inkscape, but about Open SCAD.
Yes. Okay, thank you. So,
Everyone can hear me? Any tech problem? Okay, but I can hear me, that's great. So, this session is going to be about an introduction to Open SCAD. So what am I going to cover? Well, first I'm going to cover the introduction. I'm going to tell about what this presentation is trying to do, a little what it's not trying to do, the scope, goals, and then the answer. And then a quick, in this introduction to Open SCAD, before delving into the real fast, real deep into a whole lot of details. So, Open SCAD, let me explain, right? No, there is too much. Let me sum up. So that is the goal of this presentation. It's not a tutorial, slow, step-by-step, do this, click here, drag that. No, it's going to be to give you enough of a feel for the product, a feel for some of the usage, and maybe help you get excited about trying it so that when you go to look for it, you can check the references, get the info, get going, and know which things to look for under the menus. I'm sure most of you are able to at least pull down menus and look for a command if you need to, or use Google, look for the help. Okay. So, I'm going to be summing this up. I'm going to cover the first half or so, depending if I go quick enough or not, is going to be like swamp of the basic to give you a deep, heavy immersion, just boom, into it. And then from there, a little more of the references. So the first half, if you feel lost, that's not bad. That's the thing where you go online, read the manual, there's a quick reference and a few other things to get caught up. But you'll at least have, hopefully, some clue of what was going on. So getting ready? Are we all ready to dive into this storm of information? Okay, that's better. So, goals. First goal, it's an initial push, just to get you, maybe you've heard of it, maybe you've seen people use it, maybe someone just saw it on the schedule. This is hey, go, this is handy. It's great for a few different things. I've used it for several different purposes in the last year or so that's good. I want to inspire you to use it and do stuff and maybe stretch a little out of your comfort zone. See what you can and can't do. And present you maybe with some sources to continue on with. One or two I'm going to drill in a few times, so if you at least remember those, you Google, you'll get close, and then you'll be able to continue without being blocked. And that's a big goal. And then, before we go, and first of all, I did mention the answer. Is it to the ultimate question of life, the universe, and everything? No. It's the answer to my title, and profit. Because some people might be in here, I want to be frank, upfront, this is not a money printing machine. If you learn SCAD, you're not going to get rich in 30 days. It can be a tool to help you, it can help you get along, so there are avenues for revenue, but first and foremost, I want you to just use it and get the hang for it and have fun. That's the first thing. Have fun, then see what follows. And then real quick, little aside for myself, just in case people don't know me, which probably most don't. I work on Inkscape, I have for years, 2D vector graphic thing. Way back in the day, before I committed to full-time programming, I used to, when I was still consulting, I did some programming, some art, did multimedia, stuff for game companies, did a 3D dungeon for one of the larger game publishers, modeling and animation in the days before Max was called Max. And one time I came into the offices and saw they had laid out work lights matching up to the layout of my imaginary dungeon. And it was like seeing something I created in my mind in the physical world, just even the lighting like that, was just a great inspiration to me and it turned a lot of things fun. So, maybe you'll be able to use this to get that same level of fun as you get going. So, now moving on, quick introduction to Open SCAD. First thing, the maintainers are very clear about this. Answered one of my very first questions. How do you pronounce it? Not Open SCAD. The maintainers prefer Open SCAD so it doesn't sound like an open wound. And so I can go with that. What Open SCAD does, it takes code like this and creates actual 3D things you can print out into the real world. like this. Real quick, when you bring up OpenSCAD, the interface might look something like this if you open a file. On the left, there's a code editor. On the right, there's a customizer, I'll mention later. In the middle, top, 3D view, that I find the top two most important. Below it, output, including debug and errors. So those two, important. So if you bring it up, personally, I say hide the left and right pane, hide the editor, hide the customizer. Just use this and Alt-Tab or whatever, switch back and forth to your preferred code editor of whatever form. Although the editor in here is functional and will get you going, if you're comfortable with something else, I prefer to switch in and out. So that was an introduction of OpenSCAD. Now, but that wasn't very much. That was just a little. So time to take a closer look. So let's see some more about OpenSCAD. One of the things, compare it to a few other tools. These are just the top couple that show up often when you do a search. If you want to find more, search for more. If you enter in a few of these together in any search, you'll probably find others, and certain people will have things jump out. But these are some of the top competitors, or top ones to be out there for you. FreeCAD, functionally, it's very similar to OpenSCAD, but it's all GUI and traditional CAD layout. But it's parameterized, so you can go back and change all the values later and have it updated on the fly. That's what I love about OpenSCAD, because it is code. You just change your variable, and boom, everything's magic, if you use variables, not constants. Blender, that's the name in open source 3D. If you're not familiar with Blender, look it up. They're doing a conference in LA, and okay. But that can be used for a few different use cases. It's big in movies and television nowadays also, in addition to everything else. Tinkercad, easy to start, web-based, designed for 3D printing and students and classrooms. And so if you just want to do something real quick, doodle around, use a 3D printer, that's okay. SketchUp, that's the big thing, but it's more architectural focused. Some people really like it too. Fusion 360 is really nice. High-level CAD actually does all sorts of stuff for you, but it's not free. If I want to use it on anything non-free, I'd have to pay the, I don't know, $500 a year or something like that. So for a CAD product, it's not that expensive. For a free hobbyist, it's very common, but personally, me trying to focus on free and open source, I avoid that a little. So when is OpenSCAD a good choice? Here's a quick example I had. When you're making parts, components, designing something, replacement parts for something, creating cases for things, non-organic, really good for that. Parametric, so that you can parameterize to change your values as you go to adjust to the specific instance. That's very handy. And then, you know, like this guy here, I could do this. I did not do this. This is an artist. I could do this in OpenSCAD. It would probably take me about 3 or 4 times longer than any competent artist, but yeah, that's still doable. When is OpenSCAD not as strong? Organic things, freehand art, sculpting, like this beautiful piece here, I really love it. Simulation and analysis for some of the more engineering-minded stuff. It doesn't do that. So that's kind of the usage, but what is it? It's basically, in essence, a coding language with a GUI to edit it and preview it, but you can also do it completely command line parameterized to compile, and your output is going to be a 3D shapefile, as opposed to, you know, a hello world or whatever. And now, there are some key concepts about OpenSCAD. When you first go to look at it, you know, you might go for the use the force. You know, just go with, no, do not do that. Your feelings, guesses, probably are going to be wrong unless, how many people here used to use POV ray or have or still do? 1, 2, yeah. If you've used POV ray, this will be so familiar, you just have to learn this specific dialect. If not, yeah, it's going to be different. They have the quick reference, the cheat sheet. Everything's grouped into groups. I know you can't read this up here. When you go home, look it up. Everything's grouped, categorized, easy to format, easy to find, you know, get an idea of what you want. Once you start to look at it, this is like the second most common thing I have up. So how does OpenSCAD work? It's constructive solid geometry. Core, that's at the core. How many people know what that means? One or two, okay. So what you do is you take primitives, you take geometry, you take the things and you build them up. You add or subtract, you say, here it is. And you can go, that operates in 2D and 3D, and there's stuff, transitions to convert between the two, depending on how you are going to need things. And there are also many ways to get similar results. So in essence, you take a shape, like a big pyramid, a cube, or whatever, and oh yeah, OpenSCAD can render stuff solid or wireframe, if you'd like. Whatever, and you can switch back and forth, and you can do solid with wireframes and all this. And so, but when you go to start working on it, you know what? I'm not left-handed. There we go. So what you do is you just find a shape like a cube or something like that, and you just cut it apart, but not with a sword. You use operations of another shape, another cube, another sphere, or another, to say, add this to or cut this away from what you have already. So, moving on, one of the big concepts is the concept of module, so naming. It's just a function. Any other language is a function, is a subroutine, whatever you want to call it. I actually like this because what do we have up here? The command module, the lunar lander module, that's what you're doing. You're making independent pieces that can be joined or separate or whatever in what you're doing. Maybe a foot, maybe something else. So that's what you're going to think of. Then they have functions that return a value. And this is, could be a single number, could be a text, you know, line of text, could be an array. In a complex item would be an array, which could have arrays of arrays, or, I mean, you can get crazy there and whatever you put into it. And then I just point out the recent versions added the let function. So function, whatever name equals let, and inside the parentheses you define locals just for that function. And there's a reason why that's a good way to do it when you see how the language is structured. And then other than the 2D primitives, you have 3D, you have the Boolean operations, which is subtract, add, or intersection, generally, and various transformations that can do all sorts of things for you. Move, rotate, skew, size, multi-matrix, and Minkowski, which is fun. Next thing, moving into the land of the declarative tree. So this is the core to understanding how OpenSCAD works. And this took me a little bit to figure out when I got going. What you want to do is think of it, it's a tree of things, although like most computer trees, you go the other way. You start at the roots and you build up the nodes, combine until you get your final result at the end. And it's declarative. It's not, you don't store a value, check a value, store a value, you know, wrong kind of function. You say, here is this, there it is. So you're building this tree out and not just sequencing function calls. How many people program in Lisp here? I think I got 2 to admit it. Yeah, so you know, sometimes you have to switch the way of your thinking, but once you realize that is the case here, then it all becomes much easier. So that's why I like to think about the word, when I'm working on it, emit. So you're going to, as you're working through the code, it's emitting what you're doing. Boom, that's it. Your code done. You're not interacting, storing values, changing values, similar to XSL style sheets, make build systems. Who here is a GNU make expert? Just me? Yeah, I know. The thing is, it's declarative. You say, it's a thing, not command. Do this, add this, subtract this. Not so much. And that kind of leads on to the trick about variables in OpenSCAD. So you don't get tripped up. They're not variable. If you set a value and down later you set the value again, everything that used it uses the last value you set. So the last value wins. So only set it once, except when you go into a different scope, inside of a module, inside of a function or something like that, then you can declare a new value for that variable, overrides the previous value, but stays around within that scope and things it calls. So you might accidentally set something and call a function that calls, or invoke a module that invokes a module that calls a function that has a module that accidentally uses one of the values you changed and everything breaks. So remember, it's from that point in the tree down that it's going to change. And then of the variables, the naming, standard programming naming, except for the ones that start with a dollar sign. Those are magic. Meaning they're reserved, and a few of them are used for special purposes. And there are some that you care about. $FA, $FS, and $FN, and I'll explain that later. $T, another one I'll explain later. But then moving on a little more quickly, let's see, yeah, we're still doing okay. So here we have the details of the language. A little more information, a little more important, now that you've got swamped with just hopefully the idea that, yeah, it's a little different from the languages I usually use. So slowing down a little to cover a little more of the detail now. Control and lists. So you have the primitives I mentioned, but then you can do things. You can set one or more variables in a for loop. And then the syntax for a for loop is interesting. You can have it for from start to end. You can put a step in between. Otherwise, it defaults, I think, to 1 normally. Or you could just do a comma-separated list of a whole bunch of values. If they're not calculatable, you can just a random loop 5, 17, 21, whatever, and it'll all work. Although if you're doing the start, stop, end, the rounding might not end where you expect it to end. So sometimes if you only have a couple, I'll either just list them with commas, or I'll add a 0.01 to the final number so that it gets included. Check for that, because that could be tricky. And who here codes in Python? Anyone? Okay, a lot of people, almost half at least will admit it. So if you're familiar with Python, you might know about list comprehensions, similar kind of aspects to that, what I declared there in the for loop I showed you before. They're magic. I love them. So far in all the languages I've seen them, mostly Python, it does a wonderful job, and you do whatever you want. Although here in OpenSCAD, I consider that an advanced topic. Once you start to get the hang of it, look in the details in the manual and fine-tune your expertise. But know that it's very similar, know that's what they're called, and know that you need to try to see. If not, you can just use the for loop examples like I had there. So that will get you started. Now, primitives. You're building up constructive solid geometry, CSG, combines primitives. What are they? In the set of 2D primitives, we have circle, square, polygon, which is your, okay, it's not simple, let me give you the individual points, here it is, boom. So that's the freehand one, whatever. Text, and then import, where you can import a DXF or an SVG, and SVGs can be very handy. So let me put on my Inkscape hat for a minute. So you can bring it into OpenSCAD and do things with them, and like this logo right here, I brought it in, cleaned it up in Inkscape, brought it in OpenSCAD, printed it out a couple different times, different sizes, meshes, really handy. But that's a whole nother talk in and of itself, so hopefully we'll have another one following up. And then projection, that just is the key word to take your 3D things and turn it into a 2D object. I really haven't used that much, haven't had that much need for it yet, but if you do need to go from some 3D down to a 2D representation of something, look up projection. Now we have 3D primitive. Sphere, cube, cylinder, polyhedron. Polyhedron is like polygon, but you specify the points and the faces. So if you really love coding 3D shapes by hand, which unfortunately I do, you can use that. Linear extrude, which, let me grab my little guy here. One way you could make this, I could take cubes are not all one-sided. It's actually a rectangular solid. So width, height, and depth is how you specify them. I could take 2 cubes and chop one off the other to get this triangular prism. Another way is I could take the triangle itself and just extrude it. There you go. Now you have same thing, different ways to get the same results. And then rotate extrude is kind of similar, except it's instead of pulling out straight, it will spin in a circle, or a partial circle if you want. So depending on what shapes you're trying to come up with, like if you're trying to do a vase, you just do the points for the outline and then say rotate extrude, boom, you've got a beautiful vase, or an eyeball, or whatever. And There's some parameters that can tweak it, especially like linear extrude. You can make it shrink as it goes up or grow. You can twist it as it goes up. You can scale it. There's a lot of interesting things, but if you start with the concept of extruding, and then I think like the manual mentions that's like a Play-Doh extruder pushing stuff out, whereas rotate extrude is like a potter's wheel. It's okay. I have some other interesting ideas, but that will get you going. Now, some of these, the primitives might not look like they have enough for you to go with. So what we want to do is look at what's missing, and there's some secrets from how they're solving, what problem they're solving and how they're solving it, and then there's a little few hidden secrets inside the shape types themselves. So secrets, we like secrets. Let's see what we have there. Oh, remember I told you circle and cylinder were primitives? They're not. They don't exist. Rather, these are the keywords in the language, but you're not actually producing those. They're actually regular polygons, n-gons. So it's just an arbitrary number of straight lines connected to simulate a circle or a cylinder. So, and even though I think some of the common formats for exporting do take circulars and other stuff, that's not how this operates. It's by creating polygons. And anyone who's done a game that ends up eventually into something that can be tessellated into triangles. Yeah, there are no round things. You know that. And then when they're doing these approximations, you have some of those magic variables I mentioned earlier. Also, the trick is when you're doing one of these polygon, drawing to a circle, and it's approximating it with straight lines, the straight lines are inside of the ideal circle. So that might trip you up later if you didn't know it. And then there's this one of the first things I figured out, there's a very simple magic formula so I could figure out how to specify a size to get a polygon to be outside of the circle. If I'm trying to make a hole for something to fit in, it's got to be the size I say, not smaller. Or it could be a little bigger, but not smaller. So that's the key there. So these magic variables I mentioned, the first two, they're calculated from each other. So $fs is the minimum size of a facet or an edge. So when you're circling it, how big do those have to be? You don't want that to be too small because the smaller it is, the more shapes you're going to have, the longer it's going to replicate, especially when you have a whole bunch of things to render and produce. $fa, minimum angle for facets. I'm trying to remember what word they use. I'm using facets here. That means if I'm going to do a specific angle for things to be done. So that I don't care about the size. Maybe I'm having a smaller one and a bigger one and I want to make sure they match up. You can do that. Or $fn just says, make this many of those. So that lets you specify how many you're going to do. And that's where you get the primitives for pentagon, triangle, even square. It's a circle with an Fn of 4 is a square. Circle with an Fn of 3 is a triangle. And so that, okay, there's a lot of my missing shapes. And if you set $fn, by the way, two things. Remember, it's going to override the defaults, so you might get weird effects. And if you set it as you're thinking of your tree from top single root all the way down as you call each module, and that module invokes a module, if you change fn, it'll stay changed until you change it again. So be careful. And then here, okay, I mentioned the magic. I have to let you see the numbers. Don't worry about the picture so much. This is just for illustration, but showing you that here I have a red circle is what I've specified, and then the polygon is inside of it, so its corners are touching. But if I use this math, suddenly the edges are outside and touching, and the corners are way outside, and that's the green circle there I've got set up on the outside. So very simple. I mean, look at that math. What? Divide by cosine. Okay, that's not hard. So, and by the way, the trig functions are in there, so you don't have to write your own. It's all built in, so all the handy stuff. And we'll get into some details about the math on that in a bit. Next is the secret life of cylinders. So first of all, there are no cylinders, right? That's one secret you now know. They're regular edged polygons extruded into a prism of whatever number of sides. But not only are they that, they're also cones. So you can, now this one I did not do a graphic on because I don't want legal issues. You can either pick, you can do radius or diameter for your cylinder or circle, or you can, for a cylinder, R1D1 or R2D2. What that is the R1 or D1 will give you your first radius or your first diameter, and then the R2 or D2 will give you the radius or diameter on the other end of the cylinder. You've got a truncated cone. You've got a trumpet. You've got a lot of interesting things going on there. Just remember, pick either R1 or D1. Don't have both of those. And if you have one of them with one, have one of them with two, and you might have to switch the sizes because maybe you put your big one first and it needs to be second or whatever, depending on your lines. So that's another interesting thing you can do with cones. So it's in the basics, it's built in, it's a basic thing in the language. Take advantage of it. Breathe. Next topic. Boolean operations. These are what you do, and when you're writing the code, you write this like a function. Notice this is not a tutorial, so I didn't put the code up here, but it is so easy to find. So I just want to be clear again. So union puts two shapes into one. You can also do curly braces to group them together for other operations, but then whatever's outside is performed on each one independently. If you're doing a few complex things or setting colors or other stuff, that might make a little difference. Difference cuts the second one out of the first. So, and if it's a complex shape, it will do something else. And intersection, only the overlap between the two things, first thing and second thing. Now, Boolean operations, like I mentioned before, work in 2D and 3D. Also, union, pretty dang fast. Difference and intersection, really slow down depending on the complexity of what you have. Because think about if you have a really complex spaceship and you want to cut out the path of a meteor going through it, how many different shapes is it going to have to check for intersection and all that? So one of the tricks here is to try to, if you're going to do Boolean operations that are simple, and in some 2D before you extrude or rotate, do it in the 2D land, it'll be a lot faster. I've not been able to, in basic tests I was not able to measure a difference between union and difference in 2D land. 3D is like exponential, oh, crazy. So some of these operations are coded really efficiently. And then the other thing is, math is your friend. New section. So who here loves math? Oh, a quarter maybe. Was a third, then suddenly a quarter because they thought about it and said, oh yeah, wait a minute. I can do math, I don't love it. Okay, here, math is your friend. Do the simple math. Makes it easy, makes it work. Make it be your helper here. Don't be afraid of it. And if you need to, do some web searches, find what you need. So when we're looking at the math involved in OpenSCAD, a couple of things very, very important. First, the trig functions operate in degrees, not radians. So if I want a whole circle, it's 360, not 6 point. If I want half a circle, it's not pi. But if you need to use pi, it's already defined for you, so you don't even need to define it. Although like half the time I do. Just out of habit. And then the other thing is that rotation starts on the right and goes counterclockwise. So depending on if you coded different 3D engines or 4 different 3D engines in the past, this might come up. Is it left hand or right hand rule? What that means is if I put out my right hand, close it and curl my fingers into a fist with my thumb pointing out, thumb is pointing away from the page, my fingers are curling in the way that things will turn. So that, my wife will walk through me, see me, I'm coding something, and suddenly I look like I'm hitchhiking. I'm just like, okay, what way do I need to rotate? Okay. And then the other helpful thing for, especially if you're not as comfortable with math, need more practice with math, that's what I'll call it. I won't say anything else because, don't self-sabotage. Because math, you can see, is a lot easier. If you put in a number in a 2D or 3D and you see your thing jump to the left when you want it to jump to the right, oh, I need to make that negative or positive instead of positive or negative. I need to flip, easy to see. Also, you can write, now, I mentioned the transforms. So the transformations you can do on them. Go and look them up on the reference, and they're on the cheat sheet. But they are like translate, which moves in a position. Rotate, which spins around the origin. Those are a couple. So if you can put those all together, but sometimes when you rotate in all three axes at once in the 3D space, it might do what you want, but it might do the exact opposite and flip completely wrong. But if you had rotate, rotate, rotate as three separate commands with three different values in there, then you'll be with only one X, Y, or Z being rotated around at a time, much easier to control, much easier to see. And then I mentioned one thing, you move to center, rotate, because all rotations go around the center. So if you have something over here and you want to make it turn, well, what you do is you move it to the center, then you rotate it, then you move it back. Really simple. But by the way, there's a secret there. When you're doing this move, rotate, move type of doing things, you do it over and over for each thing, can make it really easy to function. You're working with polar coordinates, advanced mathematics, and it's trivial when you're doing it like that. Sometimes, so I'll either move over, rotate, move, or I might do x times cosine 45 plus y times, sometimes I'll do that. That's the other way to get things where you need to go. But you do what you want. And then, what is the matrix? So who here knows matrix math? Who likes matrix math? Okay, couple know it, one or two maybe like it. If you like it, you can use it. In the dot operations, all this standard stuff, if you understand it. For me, and the keyword is use multi-matrix. So if you're trying to apply a 2D array that isn't a matrix, that's the keyword that will do it for you. You can build them up so that they add together, but I usually don't do this because it doesn't work for my brain as well. I mean, I've written simple 3D engines a few times, so when I'm back in it, I can get up to speed and produce matrix stuff, no question, and I understand it all. 3 months later, it's not in my head anymore. So if your brain works like this, good, it's in there. If not, you don't have to use it. You don't even have to know it's there. And see, moving on, good. Now we're up to some of the more interesting things you may not get from doing searches to try to get started and right offhand. But the one thing I found really up quick is animation for debugging. How many people use animation for debugging already? Ooh, 2, good, good. So for the rest of you, animation in OpenSCAD is very simple. There's a variable. Oh, look, that other magic number or magic variable I said you might care about. This goes from 0 to either almost 1 or 1, depending, and there might be bugs and some people have issues. But when I'm using it for debugging, I don't really worry about that final precision. And it's based on how much, if you say, I want 18 frames per second, it'll go from 0 to 1 in 18 or 17 or 19 steps, give or take. But roughly, if you go 4 frames per second in the GUI, then you'll get 0, 0.25, 0.5, 0.75. Other times you might get 1.0 added at the end, depending on the math and the rounding and all sorts of other stuff. So you set that in the GUI and it starts animating. You can save that in a sequence of files to put into a GIF or something else or put as a video online. But if we're debugging, we're not doing that. So when might you use animation to debug? Test motion. I had, let's see, I have a couple parts here, which could turn and move if I disconnect things without breaking them. Yay. I have a piece that spins. Yay. But it's got corners. If it gets too close to the wrong thing, it will hit and collide and won't, in the physical world, I won't be able to make it move. Well, if I take my two pieces at the top level and put them on an intersection and animate, then I'll only see something on screen when they overlap. Of course, that also means when you're doing animation to debug something, you might have to bump up the frames per second or number of steps to get enough steps through there so that you can see it so you don't just skip right by it. So that's handy, and in fact, when I was working on some of this set of things, that came up because I printed one set of things, put it on, tried to turn it, snapped. Oops. Oh yeah, I'm like 2 millimeters off on one of the corners. Start animating, throw it in intersection, boom, there it is. Yep. Fix my numbers, boom, it's fixed. Now I can print. To test via sliding slicers. This is an interesting thing, is that if you remember, intersection shows you two shapes. So if you take a box and just move it across your final thing back and forth, it'll do an X-ray that cuts through different areas as you go. The first time I did that, when I was trying to do a rotating maker coin piece, was just like, oh, with built-in bearings, print and plays, oh yeah, it saved so much time once I started doing that. So you have a cube, you translate it by something, either X, Y, or Z, or both, or all, whatever, multiplied by $T, so it goes from 0 to 1, it will go zoom across. And then another thing is to test parameters. What I mean by parameters is just, oh yeah, probably have to call those out separately. It's a coding language. You have variables. Any one of your variables could be a parameter. Like you have wheel diameter. That could be a parameter. So if you check if your code works on small wheels and big wheels and you want to write generic reusable code that can work on both, if you animate it like 100 times $T plus 2, so you don't get a divide by 0 anywhere, then suddenly you'll see that, yeah, when your wheels get over 10, everything else breaks. So you can use it to animate your variables, your parameters, your settings. But here's something from my multimedia days. Linear animation is jerky. If you go to animate something, it's going to be start and then stop. Whereas if first trick I do, I use trig. Either multiply cosine or sine. It just means start at 0 or start at half or -1, depending on what you do. Then it will speed up and then slow down. Then go back, and it looks a lot more natural. And the reason I say that is important when you're debugging is it's not just for aesthetics. What that really helps for is your brain. The human brain is just, and especially the visual processing centers, so amazing. It will catch all sorts of things if it's in the realm of what it's expecting to see. So if you do a more natural, start and get speed and then slow down, because nobody moves full speed 0, full speed 0. Your brain will catch things a lot easier. And then you can tweak with all sorts of other tricky parameters like that. So that's just like, yeah, so it's not just for cartoonists. Programmers can use animation in their programming jobs. There. Now you got that. Going to print. These things break. If you do something wrong, but that's okay. So first, when you go to print, you're going to need to use a slicer. And what that does is it takes your print, it takes your 3D shape that you've coded and saved and exported as some format. SCaLE is the most common. You bring it in, slicer. Slices it for your printer or your friend's print. Okay. I should have checked this sooner. How many people here have a 3D printer? A quarter, okay. How many know somebody who has one? Okay, about a half. So either you or your friend's printer, who's going to be now your best friend, because you know how to do things, but you don't have one of these in your kitchen, you're going to slice it and send them the sliced thing that's sliced for that printer. And what it does is it converts it into commands to do layers, set the temperature, movement rates, all sorts of things. First step in moving to the real world, and use something that lets you preview the output. Because majority of the time, when I code something new, print it in the slicer, preview it, slide up and down to make my layers disappear. It's like, oh, wait, that's wrong. Go back, try it again. Go back, try it again. A lot quicker than taking 20 minutes to print a little piece and realizing then that you did it the wrong way. So even if you're not 3D printing, if you're using OpenSCAD, getting a slicer to run things through so you get the feel for what's going on is really handy. And of these, let's see, few of the most common ones out there, Ultimaker Cura, Prusa Slicer, those are both free. Simplify 3D is commercial. A lot of people really like it. Slicer is what Prusa Slicer was forked off of at one point. And then there's Octoprint. Has anyone ever heard of Octoprint? Okay, so you can run Octoprint on your server, on a system, to control your 3D printer. So instead of having to put your print on a SD card, walk over to your printer in the other room, plug it in, copy it off, hit the menu, hit the wrong button, go back, try it again, get it started, and go, then walk out of the room, then have to come back and stand in the room until it's done. Octoprint lets you do that over a nice, pretty web interface, and it runs on a Raspberry Pi, so you can, put one right next to your printer, plug it in, stay in your bedroom, watch it through a webcam, all that great. It will also, you can send it the full STL 3D files and let it do all the slicing for you, but if it guesses wrong, what's going to happen? You get a bad print, so that's why I said maybe. And then now, as we're moving in a little more, printing for FDM. Does anyone know what FDM means? I believe it's fused deposited materials. What that is how the most common 3D printers you have out there, the plastic ones, that melt plastic and lay down layers over and over, fused. So that's what that is, as opposed to resin-based or light or heat or some. There are many other fancier, more expensive ways of 3D printing. You can get a really decent entry-level 3D FDM printer for around $200, a little less if you catch one on sale. Now there's a couple tricks. One, because of how they layer things up, well, first of all, visual aid. This is what your 3D printers normally are doing. They're putting out a whole bunch of rows of extruded plastic on each other. Hopefully you've gotten them straight. Maybe they're not, so they won't be as strong there. Also, if you're thinking about this, if I'm stacking these directly up on each other, that'll work. If I tried to put them next to each other in the air, they're going to fall. So you can either print with supports or at most a 45-degree overhang most printers can run through. So, and you also want to align for length, so, or strength. And then, so here is my simulated 3D printer. And this is actually how they really, almost exactly how they work. So the print head just extrudes out plastic more and more. And you're going to get, now in this case, because this is worn, I got a really twisty thing. So one of the things here is this going to fit with my other straight lines? No. And reason I did this one separate so I could beat up this poor guy like this. This will happen if your nozzle gets slightly clogged. You'll get weird prints. You'll get less printed out, so it's not going to hold together. So keep an eye on it. But be aware of that. And as you're going, align for strength. So if you have these, and then if you remember my illustration for applying force, is if I take this, I can bang away pretty much that direction, really good. But if I come this way, it'll split right offhand. So depending on how the forces are going to shear it, you're going to want to keep in mind. So maybe you print something straight up and down, maybe you print it sideways. If you've got something really weird and you want to average the strength, that you don't want stronger in one direction than another, you print it at a 45-degree angle. So everyone is slightly compromised, but not completely. Also, even if you're paying $1,000 or more for a good printer, it may or may not print out exactly how you expect it. Different plastic filaments might be slightly off. We're talking 0.1, 0.2 millimeters maybe. But when you do a whole bunch of layers all together and a lot of really fine control, that can break. That can give you a problem. So you allow for it, and also you measure it. And then, like I said, not only can each plastic, you reel the plastic you buy from a different manufacturer, print differently and slightly thicker, slightly thinner, slightly stronger, slightly weaker. If you leave it laying around and it gets takes up too much humidity, it absorbs enough moisture, it might print differently. So over time, you might get different results out of the same roll of plastic. So allow for some wiggle room, and if not, measure, see what you can do. Printer calibration is part of that process, we'll do it. But if you just allow for, I'm going to print this, my printer, I give it a 0.1, any edge I'm going to print, I give it a 0.1 millimeter extra. And when I measure the thing after I print, it gets to where I want. So if I tried to, I gave it a number, I want the physical thing to match the number, no. I give it a number, I want to subtract 0.1 so that that number is smaller, so the physical thing is the actual number, the size I want. So allow for that. And I use a variable, so in case something goes really wrong or some plastic is really different and I'm not getting the result I want, I can just change that variable at the top of my program and all the rest works. And then there's one other thing called, if you search for problems, you might find this weird phrase, elephant foot. That's where it's printing pretty good for most of it, but at the very bottom where it started on the plate, it's a little bit wider than its normal extra. So you can really get down with the micrometer and tune it and do this and that, or, I mean, if you per plastic every day, or you can be like me and be lazy and say, well, no, instead, let me just make all my designs so that they have a slight taper at the bottom so it looks pretty. And it won't bump up against the piece next to it. There, they fit, you're good. And then a few more hints. So this is for people taking notes, and there'll be more later. Also, if you go and download this probably tomorrow, all the bonus features will be at the end of the presentation as extra slides where I'm throwing in all sorts of these detailed numbers, which you don't care about sitting here now, but 2 months from now when you're trying to do this, you'll care about them. So I found that when you do one of those little clip, you're going to make two parts join together. You do a clip, standard plastic snap together kind of thing. If you make it twice as wide or twice as thick at the base, it gets even distribution of its stress. If you have it thick all the way through, you're printing too much plastic and it's not as strong as it could be. Also, if the corner at where it hooks on is sharp, more stress, it's going to break. If you round that in what they call a fillet, then it will be smoother. And if you're printing one of those snap fit pieces that you want to move and hold together afterwards, you want that rounded diameter to be half the width of the thickness of your clip part, whatever that is. And then support ribs and gussets, which are, well, raised pieces connecting either two pieces or just to the floor. That would be a gusset. Connect between two pieces would be ribs, basically. You can make those thinner, 60% thinner than your main walls, and they'll still do a good job. And then here's the thing. If you want to find this type of number and everything else, I'll dig up, I found 2 different PDFs of like research papers published by a couple big companies for injection molding. So when you're going to print thousands of things, you want to have it engineered correctly because casting a metal die is really expensive. Putting the plastic in it and taking it out, that's cheap. So they have some good research so that you don't do the wrong thing up front. And then you can collect whatever you're doing that's pertinent to what you want, some note, maybe just a text file somewhere or something. Just collect up the tidbits as you hit across them, because you might be looking at something else and suddenly you realize, oh, I might be able to use this. Let me make a note of this so I remember. So those are handy. But for those of you who actually do manage to at some point code something, even just a cube, because that's a good hello world, because then you can measure your printer performance and see if it's all wobbly or not. But as soon as you go to print your first thing, it might go wrong. So what do you do? Isn't this beautiful? You can see, I'm not sure if you can see, these round pieces I have are kind of turned into springs because they didn't hold together. The other thing, that's supposed to be a penguin, that big orange pile of spaghetti. I got up, I went out when it was supposed to be done. I watched it for the first quarter of the print, and it was perfect. Came back after it was supposed to be done, spaghetti. That's what happened. That is my penguin, just it didn't quite connect. So there could be, okay, what happened? Like the dark circle thing, oh, that's a penny for SCaLE, by the way. The dark circle things that turned into springs, I've had this happen before from 2 different sources, hardware failure. One, there's a little spring arm that holds the plastic against the roller wheel as it pushes in. My spring arm was plastic and broke. So it stopped holding enough tension. So I got that weird under extrusion springy shape. Could be I designed it wrong. Maybe wait a minute, I'm trying to print a tiny little chair with spindles that are only 1 millimeter diameter. No wonder it can't get those straight. Let me make it a little thicker. Orientation. Oh, I'm printing a chair with a whole bunch of tall, thin spindles that have to do a whole bunch of teeny tiny circles on top of each other to make it work. What if I just lay it on its back? Oh, now those are just one big long, one straight solid extruded piece of plastic. Okay, this will hold up. A whole bunch of little tiny circles won't hold up nearly as well. Lack of supports. Maybe you tried to print an overhang that was too overhanging, and most slicers will add supports, so they'll print little temporary pieces under it so that when it comes time to do that piece, there's something there for it to print above, and then you can break those off afterwards. And then lack of adhesion. And again, this is just a quick summary of some of the most common failures and their names, so you know to look it up. That's just when maybe I was printing something like, oh, that's what happened to the penguin. I was printing the penguin, he was going fine, then about a quarter of the way up, his feet didn't stay on his bottom, didn't stay stuck to the print plate. So instead of the print head moving around the penguin, it started just moving the penguin around the print plate, and yeah. So in my case, the only thing I needed to do was get an Elmer's glue stick and just go real quick before I do a print. Perfect adhesion. If that was the problem, if it wasn't that my nozzle got clogged or a physical part broke, or so check to see which reason, because they can all cause you similar things. And then from here, trying to do a little bit of wind up. A couple places, Yegi, 3D search engine, finds the thing. Thingiverse, that's where people share mostly Creative Commons license of one form or another things. You can download and print, edit, remix, and they have the customizer thing. So you can go on the website for the customizer shapes, flip parameters in the GUI, say, give me this STL, and they'll give you the STL ready to print. So you don't even have to download the OpenSCAD file. It'll do it for you on their web server. Only for older versions, not the most latest release. Then there might be more specific places depending on your use case and your need, and if you're trying to sell, there's a lot out there, so tell me which ones you guys end up liking. And then money. Ooh, yeah. Might be able to get it some. So sometimes you can make money making physical pieces and selling the printed thing. You either print for someone or print a design. You could sell the model. You can create a 3D model and sell that. Like, I think the wolf model I showed earlier, that one is like $3. If I want to go online, just buy that one model. Then I can print it as many times as I want. It's like, oh, okay, that's not for me. That's not too much. I can afford that, you know. Or you might design custom parts for somebody or something or some project, and that's a good way to, oh, you know, I could 3D print something that will make that work, and then we can ship the product or project if it's something else. And then just printing for others. Sometimes some people will get a 3D printer and say, hey, no, you'll be competing against some other actual companies doing this, but you can say, hey, I have a printer, pay me $5, I'll print that thing out for you, send it to you in the mail. You know, so those will get you started. Just those aren't the only ways to make money from this. However, personally, I think having fun is the most important thing, because you can write code and get the thing in your hand. So then that's probably the first step. If you're having fun, then you can continue to make money. If you're not having fun anymore, go do something else. And you have control because you're doing it. It's your code. You can write it. And you can also collaborate, talk to others, put your shape up, ask people to give you feedback to help you. And hopefully that will help you get going, at least know where to look to get started. So do we have any questions?
If I want to get help from more advanced users on how to do things in open SCAD, where should I go?
Good question. I need to look up. It depends which kind of users you're looking at. I am just starting out in the community. The maintainer now is in Europe mainly.
Yeah, no, I'm more thinking about, you know, how do I make this shape? Not, I found a bug.
Yeah, no. He actually knows some good shapes and is supporting usage of it. But there are Thingiverse has a lot of message boards, and also the other first place to look is Reddit. There's actually a really good. There's not only 3D printing, there's OpenSCAD, and there's even Ender 3, which is my printer. Very good active communities on Reddit.
The one other thing I'll mention for both for people who don't have a printer and for people who are looking to make money with their printers, there's a site called Print-A-Thing, which is super cheap 3D printing because it's a network of people trying to make money with their printers.
Print-A-Thing. Yeah.
Any other questions?
Yes.
Well, thank you very much, John.
Oh, there's one more right behind you.
What are you most excited about in the field? Give us a snapshot of the day.
Oh, what am I most excited about in the field? That's a very good question, because I've been watching this since, definitely since I first went to speak at Linux Conf Australia, I think in 2005, where I had my talk in the top of a hall. I was talking on color management, and down in the bottom half, yeah, okay, good. And in the bottom half, Vic Oliver was doing his clarinet playing robots. I was like, oh, how can I compete? But he was doing rep, showing all the things, but it had always been hobbyist level up until about a year or two ago. And then suddenly, like the Ender 3, you know, there was another one, a mini. My friend's got, you know, it's got like a print plate about that big that, you know, 2 something for a 3D printer wasn't bad. Then the Ender 3 came out, and it's got a, 220 millimeter by 220 millimeter print bed, and that, I don't want anything bigger because it would take me too long to print something that much larger. So, but the precision on it, so to me, they finally hit the point where it was when inkjet printers hit the home use price. And I'm just waiting for it to explode from that.
How about the materials? What's happening with materials?
Ooh, how about the material? That's a good question. Most common for the plastic extruding printers is PLA, which is organic base and should break down over time. And there's a lot of, you can get custom ones with rubber, with carbon fiber, metallic. You can do conductive ones, so you can 3D print circuits in the middle of your other prints. Bronze is, I'm not sure. No, you can get bronze look. You can also get some plastic filaments that include metallic parts in them. You can get plastic filaments with wood combined. So you can do wood-like prints that you can sand, paint, and stain.
Well, he's already paying so much to get the bronzes, if we can do something that we can distribute.
Yeah. And then one other thing other than bronze printing in bronze is if you really want to go to the next level, turns out PLA melts at the perfect temperature, so you could 3D print a complex shape and then cast your metal into it.
Oh, that's what is making the mold, that's what it costs the money.
Yeah, so if you want to do the one-off, you print, put it in the sand or whatever it is, you pour the molten metal, metal replaces all your plastic, boom.
And what about capture? I don't know very much about where capture,
Oh.
how would you capture a 3D object?
Yeah, how do you capture a 3D object? There are several ways. I 3D printed a bed so I can do that. I haven't done that yet. That's going to be next. That's going to be Summer's talk. There's several different ways to do this, and some of my coworkers at my day job have done it already. So we'll see. Yeah. Okay. Thank you. Oh. And then I promised toy surprises. I have a bunch of, printed a bunch of my little maker coins in different color combinations here. So you can come up and grab one of the little things just to see what the prints are like and what you can do with OpenSCAD. No, OpenSCAD, sorry.
Are you doing the San Gabriel Valley?
Test, test. Test, 1, 2. Does that sound okay? Okay, so if anyone wants the slides to follow along, I just put the link there in the presentation landing page. So right here. Oh, yeah, that would be a good idea. Is it possible to dim the lights?
It is possible. Do I know how to do it?
Okay, yeah. The fuse box.
Live dangerously. Come on. Don't learn anything without making mistakes.
Not sure that was worthy of applause.
Personal triumph.
Now everyone's gonna fall asleep. Okay.
It's weird, the gap today encourages people to like wander off and wonder.
Yeah, if it was like 5 minutes between talks, then people would just stay in their seats.
I think we had like 15 last year, and that was like, okay, if you have to go to the bathroom, you can do that. But we weren't so encouraged to leave the room and go.
What is SCaLE?
It is astro stacking software and other photogrammetry for stars.
Oh, wow.
Taking pictures of stars and stuff. Fully open source. I don't know how to use it. I just have the shirt. It's a good shirt. Yes. You want an introduction, or you can just go for it?
Oh, I can just go. Yeah. Yeah.
You can introduce yourself.
Okay.
If that's your pleasure.
I'll wait for everyone to find a seat. Okay, let's get started. So my name's Abe Kazimzadeh, and I'm going to be presenting about producing video tutorials with open source tools. And in the spirit of open source, I have links to, well, you can get the handouts, but there's also GitHub with some of the resources to build this up. So I didn't put the images for the slides, but you can get the handouts. You'll see that there's animation for the bullet points, so if you wanted to have not animated, then this would be the link to get. Okay, so I'm a professor at the University of St. Thomas, and I've been doing that for about a year and a half now. And before that, I was working in the software industry here in Los Angeles, so that's how I came to SCaLE. As part of learning how to teach, I needed to record my lectures, and I also needed to make software tutorials. And I wanted to use open source tools. My university provides software that's proprietary for recording lectures, and you can also use that for doing screencasts, but I decided to try to do it in open source tools because it was more fun. And I'll show you about how I did that. So I wanted to share my experiences with making video tutorials and also lectures, and I hope if you have experiences too, you'll share them as well, either during the talk or at the end. I don't mind either way. So that was the intro. The rest of the talk is split up into 3 more parts. So use cases I'll go through some examples to make it more concrete, and then I'll talk about some general techniques and then specific tools to implement the techniques. So first use case is just recording a lecture. And so it's a normal classroom experience, but it's recorded. And students can consume the lectures offline, remotely if they're sick or traveling. This is kind of relevant to coronavirus. And you can rewatch difficult material, and it's good for ESL students if they need to slow things down, and if they miss something while in the live lecture, they can go back and see what they missed. And so my university, like I said, it provides software in the classroom, and it's pretty much all set up, so I don't have to worry about that in the lectures, so I won't go deep into this. But so another use case that I learned when I started teaching again, and they didn't really have this when I was a student, but I like this idea. It's called a flipped lecture. So in a normal lecture, you have the lecture in class, and then you have homework or a project at home. But in a flipped lecture, you have a recorded lecture that you watch at home, and then you do homeworks and project in class. And so this seems like a good idea, but I didn't have experience recording videos and editing them, so that's kind of one of the motivations for me to learn how to make video tutorials. So video tutorials illustrate a skill using video instead of text. And since I'm teaching software, and this is open source Linux convention, mainly cover the case where the tutorial is about software. So illustrating software and how to use it. So it would be screen capture plus voice. But I think with the previous talk, for example, with the 3D printing, there would be kind of a lot of interesting stuff doing video tutorial with actual physical, like 3D printing, for example. But I'll use the software example. And so I also wanted to practice what I'm preaching, so I made a tutorial video as a tutorial video. There's a video there. Don't open it because it'll probably bother your neighbors when it starts playing. But I'll show segments of that as I go along. And so the kind of demo case is illustrating SOZI, which is a animated presentation. And so I made this overview of my presentation here. And so what it does, it takes a SVG image. The previous presenter worked for Inkscape, so you could make this in Inkscape, but I made it in GraphViz, so it's kind of a declarative graph language. So you create this graph as a text file, and then you render it. But then you could also open it in Inkscape and decorate it, add colors and customization. So I'll be talking about video tutorials, and the main kind of topic headings are tools and techniques. And so within the techniques, I'll be talking about video, and then some audio, and then also effort estimation, so like how much time it takes to edit and produce video. And then in terms of video, I'll go over screen capture and editing, B-roll footage, the idea of B-roll footage, and shot sequences, in particular the 5-shot sequence, and some animation. So this SOZI is an example of that. And then also audio, so capturing room tone and synchronizing audio. And then effort estimation, kind of like software estimation that is difficult. I'll talk about how you can have some rules of thumb. And then in terms of tools, of course, just microphone, a clapper, and Open Broadcaster Studio is the main software that I use to do screen capture, and OpenShot for editing, a smartphone for recording B-roll footage, and a tripod, SOSI, LaTeX, and Beamer, and GraphViz and SVG for the image to animate. Okay, so besides those use cases, the kind of other more kind of abstract use case that kind of inspired me was citizen journalism. And so citizen journalism is when public citizens play the role of traditional professional journalists. And so there's a lot of examples like Arab Spring, the Japan tsunami, Ferguson, Occupy Wall Street, Haiti, earthquake. So these cases, they have people that are trying to capture the news, and they often rely on open source tools, new media platforms, and mobile phones. And so one of the jobs that I had was working at USC Annenberg School of Communications and Journalism. And so within there was a project where they made a smartphone app that tried to guide the creation of video by citizen journalists, and it kind of tries to guide the amateur videographers to create higher quality video content. And I'll explain how that app worked. Okay, so techniques. The techniques that I'll go through, first video screen capture. So that's when you record the screen, and it usually also includes audio narration. And so this is useful for demonstrating features of software, in particular GUIs. So I always kind of preferred text tutorials until I started teaching a lot of software that had GUIs. So like one example is Tableau. And so in that case, it's a little bit more difficult to give instructions about how to use software with only text. And it's also useful for bug reports too. So if you are maintaining some kind of software that has a GUI especially, and you wanted to kind of have a user demonstrate what's going wrong, they could do a screen capture to record what was happening when they were having a problem. Okay, so by default, screencasts are real time, so you just record everything that you're doing, but after the fact, editing can be useful. So if you make a mistake, then you can cut that out, or you can also add other footage to make it more interesting. So sometimes, I guess, the first times that I would see video tutorials, I just see this kind of screen and somebody talking. I didn't see who's talking, and it kind of makes it a little bit, I think, more interesting if you see who's talking. And so to add some of those other things like face, well, actually, the screen capture video that I'm going to present, it allows you to record your webcam and the screen at the same time. So that kind of covers that. But you could also record a separate video stream and edit it. So editing is another technique, and it involves cutting, arranging, or other transformations of video shots. And it's a big aspect of storytelling using video. So it's kind of the difference between plot and story. So normally, if I was teaching a class, I would ask the class, so what's the difference between story and plot? Anyone want to take a shot at it? Yep.
Plots the architecture, stories the detail.
Plots the architecture and stories the detail. Yeah, I think that's roughly kind of how it is. I guess the way that I was thinking is the plot is kind of like the sequence of events in real time, but the story is how you tell it. So you might tell something as a flashback, so it's not necessarily the same order. And so in video editing, it's kind of the way that would apply to video editing is that you would record something, but maybe you shorten some sequences of events that are less important, or you can show the final result at the beginning and then backtrack and show how you made it. But then besides just the storytelling, editing will make your videos shorter. And so that will save your viewers time, but it also costs you time. So every time you edit, you have to go back and find the spot where you made the mistake, then you have to edit it out, and we'll talk about jump shots. So if you have a mistake, so you cut it out and then put the two pieces together, it'll kind of look bad, so we'll get into that in a second. So the kind of open question that I have that I'm not going to answer, unfortunately, is how much value is added from editing and adding other kinds of footage besides just a plain screen capture and audio narration. Okay, so another technique that I want to cover is B-roll footage. So B-roll refers to supplementary or alternative footage, and the main footage is called A-roll. And so in our case, the A-roll would be the screen recording. And so this is Los Angeles, we're close to Hollywood. And so this might be kind of common knowledge, but I just wanted to go over it because it kind of, if you haven't come across these terms, it kind of helps to think of the footage in these terms. So B-roll could also be still images, or just other video, and it could be like a talking head with narration, hands pointing, or logos or branding, and it helps to add context and dramatic support, and it can also help prevent jump shots. So like I was saying, when you take error out of a recording and put the two halves together, it can kind of create a kind of not so good looking gap between where you made the cut and where the footage picks up. So if you put B-roll footage in between, it looks better. And so that's another use of B-roll footage, and that's called a cutaway shot. And so the tip is to collect B-roll footage, so you can use that to kind of put in when you edit out a mistake. You can put a B-roll footage to prevent the jump shot. Okay, so the next technique is shot sequences. And so if you combine A-roll and B-roll, you build up shot sequences. And it's kind of like design patterns for software, but it's for cinema and television. And so the one that I used is called the 5-shot sequence. And so that's a formulaic sequence that I was inspired from the journalism colleagues. And so it's a sequence of close-up of the hands, then a close-up of the face, a wide shot of the environment with a subject in it, an over-the-shoulder shot showing the action from the subject's perspective, and a creative shot to capture something unusual perspective or something else that the viewer should know. And so I was inspired by this from that app that I was telling you about by Melissa Ludone and Andrew Lee at the USC Annenberg School of Communication and Journalism. So Andrew Lee, he wrote a book about Wikipedia, so that's kind of, he's kind of involved in other kinds of open culture projects. And so here's an example that I put at the beginning of the tutorial that I made as a demo. I think I have to record. So go back. Okay. So this starts with the close-up of the hands, just to refresh. Close-up of the hands, close-up of the face, wide shot, over the shoulders, and then a creative shot. So the unusual perspective is my coffee maker. Oops. Okay. So that's the wide one. This is over the shoulders. So, hi, thanks for watching my tutorial about how to make video tutorials. So that's kind of like the idea that you would maybe have like something boring, just a screen capture, but then you could add a little bit of creative stuff at the beginning, and you could even like record most of this and just keep the last little bit where you introduce whatever you're going to do for the tutorial at the very end. And so you could save those clips and reuse them. Okay, so the next technique is animation. And so animation, I'm not going to go into this in a lot of detail, but it's just, you can think of any kind of moving non-video stuff as animation. So screen capture is almost like animation. If you have the mouse moving around and then you record it, that's kind of like animating the mouse. And also slideshows like I'm doing right now, it's kind of animating the bullet points. And so SOZI is the one that I demoed earlier, the visual outline of the talk. And so that uses an SVG canvas to build animated presentations. And so the way that it works is actually similar to how you would animate in a web page. So if you
I don't know.
I don't know what the shortcut is to show it, but
F5. Oh. LibreOffice is not part of KDE. KDE has its own presentation suite and word thing called Calligra, but spelled with a C, not with a K. Anyway, I'm Mike Semrick. I am one of the 3 organizers of the LibreGraphics track this year and all of the years. Thank you all for coming. And special thanks to those of you who stayed. This is Pat David. Both him and I are involved with Pixels.us, a community mostly centered around free software for photographers. You can find us at pixls.us. This is Nathan Willis. Not involved, but one of the 3 of us has a great picture and the other 2 of us don't. So we've got 65 slides. This is the state of the LibreGraphics talk, and we are going to pepper you with bullet points for hopefully less than an hour. So a special thank you before we begin to a lot of people whose names I cannot pronounce, so I won't try, but they actually contributed directly to this presentation so that we didn't have to go find out what actually happened in their projects. They told us. That's amazing. So thank you to them. We're going to start with animation. Obviously, we start with Blender. Blender's amazing, and they should probably have their own track if they wanted it. But this year, the 2.8.x series has been released and is releasing a brand new rewrite, a much sought after left and right mouse click in the 2.8 series is now very predictable as to what it does. New quick favorites menus, new workspaces, Eevee, the real-time renderer, which is great. You don't have to wait for your animations to render down. And you can now do 2D animation with the grease pencil. There's a movement inside of Hollywood to move to Universal Scene Descriptor, which is a file interchange format for moving descriptions of scenes between both proprietary and open software. They also have the MantaFlow system and the Flip Solver. They were the lucky or recipient of the Epic Mega Grant, which is from Epic Games. They set aside $100 million to give to projects that are trying to further the tooling for the video game industry. They got $1.2 million in cash, which is crazy. They'll also be holding their own conference, BlenderCon, at the Henry Fonda Theater here in Los Angeles, June 1st to the 2nd. Tickets are on sale now for $199 if you need your own 2-day conference for Blender. This is their latest release video, but without sound. Oh, I do. Awesome. We need some good tagline like creative freedom starts at blender.org. That is good marketing. Do we? Synfig Studio is another 2D animation software. They had the 1.3.12 release on the 7th of February. This is a beta version, a stable beta version of the upcoming stable version, 1.4. They're now caching their rendered playback to make animation smoother. You can set a custom playback range and loop the playback. You can import video, and you can export animations in web-optimized format. They were accepted to the Google Summer of Code for this summer, so Google will be paying somebody to improve their software, which is awesome. OpenToons is another 2D animation software mostly used for anime and manga. It's geared towards actually hand drawing and then scanning or photographing the slides and bringing them in and doing that kind of 2D manga style animation. They released version 1.4 on February 20th with guided drawing and auto tweening. They have XDTS file support, cache folder replacement, and clearing a context-aware toolbar, and they now support capture from a Canon DSLR, which is Windows only for now. Envy is a brand new 2D animation project. It's timeline-based with automatic tweening. All objects and filters properties are animatable. It supports, for now, Bezier curves, ellipse, rectangle, text, brushstrokes. They use the very excellent libMyPaint for all of their painting, which gives them good, like Wacom tablet support, all the pressure-sensitive brush stuff, and relies on Qt's native graphics tablet support. In drawing and painting, Inkscape 1.0 beta release. Is that right, Ted? Yes, excellent. Native Mac OS app support, which is awesome. You used to need Xcorts or an X11 server to run Inkscape on Mac, which was not the best experience. Much improved, much appreciated. Canvas and mirror rotation support and alignment, high DPI support, which is awesome. Variable fonts if you build with Pango. Greater than or equal to 1.41.1 and non-destructive Boolean operations. Krita is mostly geared towards digital painting. In the last year, they received 1,236 new bugs and closed 1,272. They had 2,271 commits from 60 contributors, 9 releases with the current being 4.2.8. Actually, the first application, I believe, of any application, open or proprietary, to do HDR rendering. I believe they got money from Intel and worked closely with Intel on the HDR editing stuff. They're also accepted to Google Summer of Code with 4 students. They had over 2 million, 2.3 million unique direct downloads from Krita.org. From my understanding, their direct downloads is not even the bulk of it. The Windows built-in store makes up way more than that. They have over 1,000 active users on their Discourse instance, which is at kritaartists.org. Ooh. They also got an Epic Maker grant for $25,000 to continue their development as well. MyPaint 2.0. MyPaint is another painting application. 2.0 was released in February 2020. The major feature on that is the linear compositing and spectral blending is now used by default. If you don't know what that is, spectral blending is now when you mix 2 colors in MyPaint, it behaves as if you were actually mixing 2 paint colors in real life and not just mixing 2 RGB colors. So if you can mix paint colors in real life, you now get the same behavior in MyPaint, which was much trickier than you would think to actually code and bring that feature out. They have new brush settings, attack angle, zoom level, barrel rotation, 4 new symmetric painting modes. And a flood fill enhancements includes offsets useful when the fill does not flow into the outline sufficiently. Drawpile is a collaborative web application for drawing that allows users to paint on the same canvas simultaneously. Looks like they've mostly had bug fixes except for adding open raster format support in 2.1.17. Also lots of updates to the admin interface. Video editors. Kdenlive released in April of 2020 will mark the 1-year anniversary of the complete rewrite of Kdenlive's timeline feature. They really worked hard to improve the timeline and the stabilization, so hopefully if you're running this release, no more random crashes. They have a 3-point editing and audio mixer, huge improvements due to optimizations in the timeline and preview scaling and monitors. It supports the open timeline, which is another format to interchange between different video and graphics applications for your timeline. You can pitch shift on speed change, so you can speed up or slow down without distorting someone's voice. You can tag and rate clips in the project bin. They're working on a new titler rewrite as part of GSOC. You can record audio directly into the timeline, which might be useful if you're making software tutorials. And it's now also easier to keyframe. Expected in the coming year is nested timelines, finishing the OTIO support, audio mapping, and rerouting, finishing the new titler. The actual LibreGraphics meeting from whom we kind of pinched this presentation is happening May 26th in France. So if you need a reason to take a vacation, there you go. Olive is a new nonlinear editor since the middle of last year. It's been undergoing a major rewrite to lay a solid future-proof foundation. It has node-based processing, which I'm not sure any other open nonlinear video editor has. A completely new EXR-based caching system, which means it can handle super high bit depth images and video, better memory management, and color management via OpenColor.io. Shotcut released version 20.2.16, which implemented proxy clips, audio pitch filter. So again, you can change the speed of someone's voice without changing the pitch, and over 150 new transitions. Other notable features in the last year is a more flexible timeline, keyframes, a keyframes toolbar, and hotkeys for trimming clips, and like a lot more of everything: filters, transitions, audio effects. They have a full and very long list on their website. How do you actually pronounce this? PTV, but it's probably really anybody's guess. They were accepted last year to the Google Summer of Code and gained a redesigned effects library with thumbnails, a favorites list, and improved search-based results for the thumbnails library instead of a list-based result. OpenShot continues to plow ahead. They released version 2.5 with hardware acceleration. They can open Final Cut Pro and Premiere Pro files. They have a file recovery in case of crashes, a rewritten keyframe system, Blender integration, better SVG handling, improved thumbnail generation in the clips bin, preview window resizing, and cross-platform improvements. The aforementioned Open Broadcaster Studio currently has a release candidate 25, which brings Vulkan-based game capture. Vulkan is the next generation cross-platform graphics rendering, library, driver, API, all of the things. You can now capture browser windows, and there's a browser plugin for Linux to help you capture your Linux web browser. It now supports the SRT protocol for streaming. Version 24, which is the current stable, allows you to pause recording and automatically adjust the bitrate if you're live streaming when it detects network congestion. In the beginning or middle of last year, they launched a sponsorship program via Open Collective and Patreon. I don't know that the Patreon is still going, but they added a bunch of big name sponsors, the latest of which is Facebook. They're a premier sponsor along with Twitch, and they have NVIDIA and Logitech as diamond sponsors. Nantron is a nodal-based 3D compositing application, much like the proprietary Nuke. Sadly, development was a little stalled, but one of the main developers has come back to the project again, so they're doing ongoing bug fixes and updating to Qt5, I believe. They also joined us at pixels.us for forum support and discussion.
Mike, his throat hurts. Hi, guys. I'm just going to go through the photography session real quick, and then I'm going to turn it over to Nate for the font stuff. So, what's going on in the world of photography for free software projects? Raw Therapy, one of my personal favorite projects, but don't tell Darktable that. We just built them a new website. Mike and I did this early last year, at the end of last year, roughly. So the brand new website at rawtherapy.com, go check it out. Looks a lot better than it used to, for sure. Mac OS packages are now available. The executable now uses launch services. So the Catalina support is now complete in those releases. And the developer, Alberto Grigio, is that right? I don't know how to pronounce that for sure. Alberto, he has a friendly fork of Raw Therapy now that he calls Art. I'm another slide for it. He's got a new pipeline with it and some UI refinements. His real goal there was to make it a little bit easier to use and more accessible for new users doing raw image processing than Raw Therapy's default interface. So he's added a lot of stuff. He's got some local edits and masking modes for both drawn and parametric masks. He's got a perspective correction tool that he's been working on that's worked out very well. He's got improved metadata handling support thanks to EXIF 2 and the EXIF tool libraries. LibRaw has CR3 support now. Test it. And this happens in Raw Therapy as well. If you haven't added Ted, you asked about CR3 yesterday, and I didn't want to give it away too soon. That's my big reveal for Ted. So, star rating, color labels, and the rest of all those things are now stored in the sidecar files, the XMP files. And that project is called Art. You can actually find it at on the Pixels forums. You'll find his discussion and then links to his code and things. He hasn't really got a real good website up yet. It is our job for sure. Raw.pixels.us, for those of you that don't know, we are the keepers of all of the donated raw files from various makes and models of cameras across the camera ecosystem. And we do this so that the raw processing libraries have test files to test against, make sure they're able to decode them properly and what have you. And so we took that over, I guess, about 3 years ago, I want to say. About 3 years ago. We used to be, what was it before? Rawsamples.ch is what it was once upon a time, but that owner disappeared, and we had no further updates or availability of files from that, so we took it over at raw.pixels.us. If you have a camera that's not supported, if you visit the site and you have a camera that's not supported yet, please think about just uploading a couple of files for us so that we can make sure that we test it against the various raw processing libraries. So yeah, between 2018 and 2019, we've seen a nice increase of samples. We were up about 15%. We got 1,300 just over 1,300 samples now, almost 800 various camera models. We got the numbers down for the non-CC0 licensed samples. Part of the problem with the other sample set was they weren't explicitly licensed, and we couldn't continue to use them for some of the tests and things that we would show publicly. And so we're only missing about 165 cameras out of all the available digital cameras. And that's Roman that's mostly been working on that, and Keys or Andabata on the forums. So you can contribute. Come and give us a hand. We've got almost all the backlog for the missing samples up. Growth is slowing, but it's mostly from the fact that we're reaching that peak, and now we're just kind of maintaining with new camera models. The raw speed, raw decoding library is stable, fully OSS fuzz clean. It's got support for 35 new cameras in it. Nothing new has been added for decoders or decompressors this past year, and a lot of it was really about performance tuning and decoding of raw files, which Roman is kind of oh, I'm sorry, he's right. I assume people know this sometimes. Raw speed is the actual decoding library that Darktable uses under the hood to open and decode raw files. I apologize, I should have made that clear. Thank you. Speaking of which, version 3.0, if you guys use Darktable, was out this past year. Brand new GUI, and everything's now themable via CSS. There's a culling mode in the light table view now, panning and zooming the images. There's a timeline view if you want to select images by a date range. The light table's been rewritten to be much faster and works much better on 4K monitors. The Filmic RGB module that Aurélien Pierre has created is available now in a 3 series. This kind of replaces the base curve, shadow, and highlights modules, and any other global tone mapping is now handled, can be now handled through the Filmic module, and then the tone equalizer module. So you lets you remap tones quickly based on things like Atom's zone system. RGB curve and RGB level modules. There's a much better profile denoise module now too. You used to have to use 2 instances of the module targeting certain frequencies of noise to dampen it. You can just use the 1 instance now. You can do 3D LUTs. These are using either PNG hauled CLUTs or cube LUTs. For those of you that don't know, a LUT is just a color lookup table, and it allows you to map colors from one representation to another by saying, you know, this shade of red should now be slightly browner, and this shade of green should be slightly brighter, and then it will apply that across your image wherever those tones may occur. New tagging module, hierarchical tags and private tags, synonymous searches, and raster masks, and copying parametric masks to other modules in the pixel pipeline so you can reuse them. Yeah. And so PhotoFlow, this is created by a user on the forum, Andreas Herrero, if you don't know him. It's his own raw image editor that he created, so his workflow is based on non-destructive layers and opacity masks. It's a neat piece of software, and he's put a lot of effort into making sure that things like color management are correct and handled smartly in his application. So he's got a new user interface, dynamic range compression. He's caching things so things are moving a little bit faster now. He fixed up a lot of bugs and added some overall stability to the program. If you get a chance to play with it a little bit, it's fantastic. He first debuted this 6 years ago at LGM in Leipzig. Or was it London? It might have been LGM. It might have been 4 years ago at London then, was his first release. So that was really the first time he talked about it. He's come a long way with it since. Andreas is also a packager for a lot of projects. He's doing great work. Rapid Photo Downloader from Damon Lynch. This past year he's added support for high efficiency codecs. These are, I don't know how common they are on Android, but on iOS it's a common video and photo storage mechanism for much higher compression ratios at the cost of maybe a little bit of quality, but perceptually maybe not as much. Much better high DPI support and fixing bugs where you couldn't access the phones any longer through GIO GVFS after changes. RawProc. This is Glenn Butcher is the author of this processing. This is a one man's attempt to make a GUI equivalent to DC Raw. If anyone remembers DC Raw as an old raw decoding project. So you can check that out on the forums as well. But he's got a lot of, he's got kind of like a tool chain processing pipe where you walk through it, and then when the image is open, you'll just add you'll add new processes to the sequence of processing in the pipeline. It looks like a tool, like a tree structure when you take a look at it, and now he's able to maintain throughout the hierarchy results from previous nodes in his graph. So everything's working in 32-bit float, and he's another person that's being very careful about color management stuff to make sure that things are maintained all the way through. GIMP, it's a project I'm partial to, has had a lot of things happen over the last year. So some usability improvements in GIMP. You can now display and edit pixels that are outside of the canvas boundaries. You know, you can actually see that even though you have a canvas, things that fall outside of it are now visible and editable if you want it to be. You can edit hidden layers if you're hiding them in the layer stack. Transform tools can now be adjusted on canvas even after zooming in and out. You can go to a particular layer by pointing at any of its pixels and hitting Alt middle click is a new shortcut. Curves and filters are now more predictable and come with some different kinds of node available for modifying the curve itself. All the parametric brushes now have 32-bit per channel precision. The bucket fill tool for line art is something that Jean had shown off for the first time last year at LGM, which was in Saarbrücken. Yeah, this is cool. If you haven't seen it before, I should have put a video up. But for artists that are doing coloring of line drawings, if you have a line drawing and the lines aren't closed, you can still bucket fill in that area, and it'll close that gap for you automatically. This is based on some work he had done with the GMIC project on an algorithm for closing that gap in a smart way. Sample merged option now for the heal tool allows non-destructive retouching on a separate layer, so I can actually heal and put the results of a heal operation on a new layer, not the one that I happen to be pulling the sample from, so I can sample across the stack. That means I can turn that layer on and off without affecting the other layers in the stack, which is nice. Foreground Select has a grayscale preview mode now, and the offset tool now lets you kind of shift pixels around and wrap around the canvas so you can create tileable textures much easier in GIMP now. We have some more format support. You know, we had a lot of people suddenly spoke up about a DDS support, and it's not something that I use very much. It's a format, I think, for game engines of some kind. Is anyone familiar with DDS as a I'm not personally, but I know that we had a lot of people. There used to be a plugin, and it kind of fell by the wayside. It wasn't supported any longer, so we have it natively now. Layers are preserved in a TIFF file, and if you load a TIFF with an unspecified channel in it, GIMP will ask you how you want to handle it, but don't write TIFF files, they're insane. And now we have ICC profiles in high efficiency formats are available for both loading and exporting when we use live, when you compile with live HEIF 1.4.0 and newer. And then the underlying graphics engine that powers GIMP, called GEGL, Generic Graphics Library. This is Oyvind Kolas Pippin, if you're online. And so he's got a lot of color space work was done. This is L. Stone, who was on the Pixels forums and is well-versed in color management, was able to provide some help in getting that done. We have a lot of changes in the standalone GEGL tool. So now node-based compositing and video playback is available. Much better CMYK support, which is going to make, by my estimation, 3/4 of the internet happier now. So we'll get CMYK support much better. And he can now do much better utilization of CPU threads when he's doing some of the processing, better memory management, especially on larger images, and some work on the cubic sampler for downsampling when downscaling images. Cyril recently joined us at the Pixels forums this past month. I want to say like a month and change ago, and came on board to have all of their discussion forums hosted and handled by us. They've had a release in November. They've got a new YouTube channel they just started up with relevant videos about using it. If you haven't before, it's an astronomical image processing tool. Usually these are things like stacking and noise reduction and stuff that astrophotographers tend to specifically need. They're on GitHub now. They've got a 1.0 version coming down the road with a bunch of UI refactoring, and now they've got the floating point precision. I think it's already in there, is what I read maybe just a day or two ago. So they've got a full floating point high precision, which you need for these astrofloat. I think you can load 64-bit FITS files, but I have to double check with them. Luminance HDRs is a complete solution for producing high dynamic range tone mapped images, or just high dynamic range images that you want to create an HDR with. So they've added 4 new tone mapping operators, which I honestly didn't even know came out this year, but apparently there were 4 new tone mapping operators this year. Speed optimizations for doing the tone mapping and for HDR creation. This was mostly the work of one of the raw therapy developers, Ingo Weyrich, who's some kind of wizard when it comes to optimizing things. Post-processing gamma and saturation are now available, and you get previews in the HDR wizard creation. Anyone ever used Luminance HDR before? Oh, some people maybe. Yeah, the project is alive and kicking and moving. Same thing with HDR merge. They didn't have a ton of new things that happened this year, mostly just a migration to Qt5. HDR merge is similar in that it'll take a stack of images and combine them to produce the most noise-free result, not necessarily the highest dynamic range. So it'll shift that the exposures and then grab the cleanest sections from each of them. Geeky. This is a lightweight image viewer I'm sure many of you are familiar with. They had a 1.5 release back in July of 2019 and a partial implementation for high DPI. Multi-display full screen works a little better. They use GPS lat long to get the local time corrected for UTC offset. The markings and image connections can now be saved in a text file optionally. They got show star ratings, and they've implemented regular expressions for their searching. PhotoFlare is a relatively new project. I think I ran into the developer just last year at LGM in Saarbrücken. They've been moving quick. This is kind of a simple photo editor with some simple image editing, and he wanted something that was quick and relatively easy to use for his workflows. They've had 5 new releases over the last year or so since LGM. 25 bugs fixed, 12 new features, new translations. They've got user documentation at GitHub. They've been doing packaging in Flathead. A bunch of new keyboard shortcuts are available, and they're using OpenMP to utilize multiple threads, because I think graphics magic is what drives PhotoFlare under the hood for the most part. And he's been literally on the edge of his seat to come out here and yell at you about fonts, so I'm going to turn this over to Nate Willis. Were there any questions on the photography side before he steals this from me? Yes. There's like 4 slides, so you missed a bunch. That depends on what you mean by that and to what level you mean by that. He's asking if GIMP is truly a parody for Photoshop, and it's highly dependent on your workflow. Probably not. If you have a very, very advanced workflow where you're doing lots and lots of unusual things that are very Adobe specific, or even not so advanced. So things like adjustment layers don't exist just yet, but they're coming. But for most folks, I have yet to find a situation where I wasn't able to produce result and the same result from Photoshop, maybe through a different means in GIMP, generally. So. Sure, yeah, no, Digicam and Darktable both have like Facebook and maybe Instagram connectors. Maybe not Insta, but they're Facebook connectors for sure, Flickr connectors, and possibly more. I don't use the feature much, but I know that it exists. I'm thinking. Yeah, Digicam has like 50 export options, for example. But if you catch up with me afterwards, I can absolutely try to fill you in a little bit more if you'd like and point you to something. And if it doesn't exist, we can make it because it ain't that hard. Plugging into those social things. Famous last words. It ain't that hard. Easy peasy. I'm gonna listen to some fonts, so don't go anywhere just a minute. We got some cool font stuff coming up. So I'm gonna give this to Nathan. Are there any other questions before I hand this off to Nate?
All right, well, as the crowds pour in through the doors, I kind of split the font stuff into a couple different categories here. The big font creation tool in free software is still FontForge. It's been around for close to 20 years and still does more than almost any free or proprietary font editor out there. In 2019, there were 3 releases, which is quite a lot. It sort of ebbs and flows, depends on when there's a big change in what people want format-wise, if there's a lot of activity. The big news on that front since last year is that all plugins and things using Python 2 are deprecated now. And this is really, I mean, that's a hard change for anyone to make. It will upset some people, sure. But there are also new features, such as allowing users to decompose a glyph into components that can be reused. This is the kind of thing you would see if you have a letter that is a composite of a base letter and a diacritic mark or something like that. So more flexibility in doing that just speeds up producing large character sets. The other exciting thing that's maybe not so visible is that there are several new developers contributing to the project who have been hacking away at reducing some of the technical debt of the sort of in-house GUI toolkit that's been around since the earliest days. And so collapsing some layers of complexity there is eventually going to let it run on top of standard GTK, and that in turn makes things like better Wayland support possible. That's sort of been on the to-do list for ages, so it's exciting to see people making progress on that. A few other sort of like technical details there. FontForge now supports version 3 of the UFO file format, and this is an interchange format that a whole bunch of proprietary tools and other editors use. It stands for Universal Font Object, and it's XML based. So FontForge actually has better support than almost anything else for this. FontForge can also now produce WAF2 files, which are the highly compressed files you do when you're using web fonts. And WAF2 has a totally new compression algorithm they cooked up just for that, and it's like 40% smaller than WAF1 was. And FontForge now supports Unicode 12.1, which 12.1 was the point release where they added the new symbol for the new name of the Japanese era that changed when the emperor resigned and his son stepped up. The other thing to consider in fonts is not the editor, but what you do with it. And when it comes to that side of fonts, the big news is variable fonts, which is a change in OpenType 1.8 that allowed you to have all the different styles of a font sort of encoded into a single file as essentially deltas. And that's vastly smaller than having 18 different font files, and also lets you sort of adjust sliders and arrive at weights in between. And Google Fonts has had people working on adapting its open source fonts that existed in multiple styles into a variable font version. And usually this happens transparently when it comes to your browser, but if you want to dig into the font library, you can see which releases support this, and you can download those and use them on your desktop. And I mean that literally for people using Linux, because variable fonts are supported not just in Inkscape, as you saw in the Inkscape slide, but in all the web browser engines, Chrome, Firefox, and now WebKit GTK. So that means maybe some GTK desktop apps will be able to start transparently supporting that as well. Thanks to Matthias Klassen at Red Hat, they also work in GTK and GNOME. So GNOME apps can use variable fonts. You don't necessarily need to see all those sliders, but it's some pretty rapid adoption for a brand new and unusual technology. Maybe the other thing to consider when it comes to making fonts is that there's a lot of ways to do it. So even though I said that FontForge was still the heavy hitter, there are some other maybe smaller font projects. One of those that's interesting is TrueFont, which is a pure Python-based free software font editor. And It's been picking up additional developers recently, and it's still maybe not as featureful as FontForge, but the fact that it's entirely written in Python makes it able to use a lot of other code that exists out there. And a lot of people in the font business make utilities in Python, and adding those as plugins to the TrueFont is pretty easy. I've also seen this past year several interesting tools released as free software, even though they're designed to run on Macs. And there's two examples there. One is called Font Goggles, which is sort of an inspection thing, especially for really complex fonts that let you dig into the features and how they work. And the one that you see a screenshot of on that G is called SpeedPunk. And what that is a visualization tool that's showing you the sort of degree of curvature of the curve at every point. So when there's a discontinuity, you may not be able to see it with your eye, you're just looking at the shape, but SpeedPunk allows you to see, oh, that's actually slightly unsmooth right there by sort of exaggerating those curves. So it's interesting to see people, even if they're using a different operating system, release some free software for building fonts. And the last thing down there is two tools that are used for building and testing fonts. Getting fonts to work is a very QA intensive process. FontMake is a production tool for generating things from source, and it supports even the proprietary font formats, which means if you see something that says it's open source, but it requires a font editor that you have to pay money for a Mac, you can actually still build the font. And Font Bakery, the last one there, is sort of a massive test suite. Make sure that if you have a bunch of styles, they all have the same characters in them and they all build correctly and that sort of thing. And so those are very important tools, even though they're not maybe as glamorous to look at. I can go ahead and do the desktop publishing section. I'm going to have to wing it on a couple of them, I think. Scribus is the big GUI DTP app for building complex documents, and I think they just made one release since last year. That was 1.5.5. It's pretty stable, so there's not a long list of changes there. Dark UI theme support is probably important to some people. There are a lot of changes to the script writing engine, and there is improved support in what they call complex scripts, which are things like Arabic and index scripts where the shapes of things change as you type. So getting hyphenation and proper numbering working on those is actually a lot of work, and it's now supported in Scribus. And also you will see improved messaging when you load a document and there's fonts missing. And if it just changes, and that's not very helpful, so better reporting back is an improvement. Layout is a tool written by that man right there, which I guess you would say originally was done for page imposition, but has since expanded to cover all kinds of production workflow things that Tom uses in his projects. And I'm reading this for the first time. Automatic app image development builds, that is certainly a sort of one-click installation solution for people. HTML gallery export is new, and object bleeding across pages. I'm not sure what kind of objects those are, Tom. You have any? Okay, so objects that you have stretched across multiple pages now are properly stretched across multiple pages without being clipped and cut off. And also object clipping, I think I can guess what that means, which is that when you need to clip an object like an image around something else, or you just want to only show a part of it, you can edit the clip path easily. Is that right? Okay, great. Whew. I'm relieved. And then last but not least, LibreOffice Writer is probably what a lot of people use to make most documents. Scribus is a bit overkill. A lot of improvements in the past couple releases on LibreOffice Writer, including it's easier to successfully edit tables, moving rows and columns around needs to work, and pasting things like copying multiple cells and pasting them into multiple cells works. You can now also toggle a setting so that when you're moving objects on the page, if you don't want them to overlap, they will automatically be scooted to the side so they don't sit on top of each other. You can also write bottom to top text, which is not a different language. It's just if you want to have a rotated text object, it now lines up correctly and you can justify it. The improvements to editing auto-numbered lists are things like if you have a numbered list and you remove an item in the middle, it doesn't break the numbering. And full edge-to-edge page backgrounds, I guess I didn't realize this was work that needed to be done, but yeah, you can now set a background that does not have any margin on the edge of the page. And there's a lot of work that went into improving building forms on LibreOffice Writer and to supporting unusual combinations of features in Word and DocX, things like having endnotes and having embedded charts and things that are more complex documents. This is just about David Ravoy. Micah, how would you like to tell us about that?
So if you don't know David Ravoy, he's a French illustrator and artist. He produces mostly a comic called Pepper and Carrot. It's very good. The week before, he actually published the results of trying to use only free software to print an anthology of the Pepper and Carrot comics. It's a really great article if you are into prepress and free software. It ended up being much more difficult than you would think from the outset to use a commercial printer to produce a full CMYK document for like mass printing. So he did a ton of work, and now we all get to reap the benefits of that work. Yeah, so much like color management from your screen to your photo printer, we have the same thing for books and comics, except it's much more specific. There's specific coatings and specific paper that produce vastly different looking output if you don't calibrate for them correctly. So having this is an excellent resource if you're making comics that aren't just black and white, or trying to do any type of mass publishing. So real shout out to him. That was a lot of work, and he did it at his own expense too, and shared the results. Thank you to all of you for showing up to the third annual Libre Graphics track. If you need more graphics, May 26th in France, there is the Libre Graphics meeting, which is both users and developers. There's everything from contributing code to, last year they had like photo workshops and sketching and all kinds of things. So not just for developers, if you can make it there. Yeah, and France is wonderful in the summer, so there you go. Thank you guys for coming out, and thank you for sticking around to the last talk on Sunday.